Please welcome to the stage Chief Product Officer of Anthropic, Ami Vora.
Good morning, everyone. It is such a pleasure to see you all. Thank you for joining us. When I think about why I'm here today, I go back to the first time I wrote a computer program and it worked. I didn't grow up coding. I grew up in the foothills of the Appalachians. I never built my own computer. I didn't even play video games. The first time I actually tried to build anything complicated was in my college computer science classes. Now, this was so long ago, we had to wait in line to log directly into the servers because they were the only thing powerful enough to handle our ray tracers. This might be familiar to some of you. The hum of servers, the smell of old pizza, coffee, and that very specific aroma of a windowless basement computer lab. I can still remember that feeling of hitting compile and waiting to see if my program worked. That feeling of joy, discovery, a little relief, and the excitement that I had made something that had never existed in the world before. That's what hooked me, and that's why I'm here today. But so much has changed. What I could only get by waiting in line at a college computer science lab, that's available to anyone, any day of the week, anywhere in the world. No line, no weird smells, and no barriers. Just that same feeling of excitement, joy, and relief. And I know a lot of you feel the same way. People say to me all the time, I feel like Claude has given me superpowers. It's one of my favorite things to hear. And we're seeing people use those powers. For instance, Scott McVicker runs developer infra at Stripe. One of his teams had 50,000 lines of Scala that needed to become Java before they could upgrade their JDK. The initial estimate was 10 engineering weeks. They used Claude and finished in 4 days. And sometimes speed isn't just about efficiency, it's about what's waiting on the other side. Felicia Kukuru is the co-founder and CEO of Binti. Her software runs the systems that caseworkers use to place kids in foster care. The paperwork, the home visits, the licensing process. This year, her team used the Claude API to give caseworkers back hours they used to spend on paperwork. That took 20 days off the process of licensing a foster family. 20 days. It's not just an efficiency metric. That's a kid connecting with a family. And that excitement, joy, relief, that feeling of discovery, it's something I hear from everyone. I'm going to guess, though, that everyone here experiences it differently. Some of you are living on the frontier every day. Some of you are bringing along the people around you. And some of you came here because, like me, you can feel the ground shifting under us, and you want a view of what's to come. Trust me, I feel all of those things often in the same morning. I come to work with a plan, and then I have to tear it up by lunchtime because something new has happened. Does that sound familiar? And that makes sense when we step back and look at how fast these models are getting better. At Anthropic, we talk a lot about the exponential, and I think that's what we're all feeling right now. Remember, a couple years ago, the frontier of model development was something so good it could write a decent email. And we were pretty happy about that. A year ago, we were standing on this stage. Opus 4 was the headline, and the idea that an agent could run for an hour without a human checking in felt like a stretch goal. But then 6 months ago, agents were running end-to-end overnight, so we'd wake up to finished work. And then last month, Mythos read the entire OpenBSD source tree and found a 27-year-old vulnerability that had survived every human reviewer, every fuzzer, every static analyzer thrown at it for almost 3 decades. The jumps keep getting bigger, and the intervals keep getting shorter. But even though model capabilities are improving on an exponential, most organizations are still adopting AI on a linear path. And that means there's a gap between what AI can do and what it's actually doing for people. Closing that gap, translating model capability into something real people use to solve their problems, that's what developers do. That's what you all are doing. And we're seeing it happen. Year over year, API volume is up nearly 17x on the Claude platform. And on Claude Code, the average developer is now spending 20 hours per week running Claude. Now, like you, we've been shipping a lot lately, and we want you to walk away from today with a clear picture of where we're headed, so you can plan for it and ride the exponential with us. Let me say up front, we don't have a new model to unveil. Today is about how we're making our products work better for you, so you can close the gap for the rest of the world. And this morning, we'll show you what that looks like. First, Diane will talk about our foundation, the model layer. She'll share more about our frontier models and what's coming. On the Claude platform, we're shipping updates to Claude Managed Agents, outcomes, dreaming, multi-agent orchestration. And Angela and Caitlin will walk you through how the platform handles the infrastructure, so you don't have to. And on Claude Code, Kat and Boris will walk you through how you can use new primitives, like routines, to let Claude Code prompt itself, even when you're away from your computer. But all this comes back to you and what you're going to build. Because most people will never call the Claude API. They'll never open a terminal and type Claude. They'll experience AI through something one of you built on the Claude platform. Whether that's a designer exploring new directions with Canva, or a lawyer getting a brief out the door faster with Legora, or a developer using any one of the world's best coding agents. So thank you. You all shape what AI feels like for everyone else. We'd never be able to build everything that people need to solve their problems. That's something only you all can do. And one way we want to show our gratitude is by sharing a little exciting news. As of today, we are increasing rate limits for developers on Claude Code and the Claude platform to help you keep building and closing that gap for the world. More specifically, we are doubling Claude Code's 5-hour rate limits for Pro, Max, Team, and seat-based enterprise plans. And we're raising our API limits considerably for Claude Opus. We're making this possible by expanding our compute partnerships. We're partnering with SpaceX to use all the capacity of their Colossus One data center. And we're investing this directly into individual developers and small teams. Over time, we'll continue to explore every way to help you get the best out of Claude, including our existing compute efforts and even bolder bets. So thanks for being here today. Thanks for partnering with us to shape what AI looks like for the world. Thanks for giving people superpowers. Up next, Diane, who leads our research PM team. Thank you.
Congratulations. Thanks, Ami. I'm Diane, and I joined Anthropic back in 2023. And I've been a part of every model since Claude 2. For those of you who are counting, that's bringing 18 versions of Claude across Haiku, Sonnet, Opus, and now Mythos to users and developers like you. We wrestled with making Opus 3 great at adhering to JSON and also making it the best at writing long-form code. With Sonnet 3.5 New, or as we all now finally know it, Sonnet 3.6, we taught Claude to make and use a computer safely. And with Sonnet 3.7, which had a tendency to be slightly too overeager, we figured out the right way to expose that to users and developers so you could get the most out of Claude. This time last year, we used Claude 4 to be able to use thinking dials in a way that worked well and to address test time compute. And we haven't slowed down. In the last 12 months, we shipped 8 frontier models to developers and users, each one building upon the last, allowing you to write better code and the products you build go further than previously before. The model layer underpins everything else you'll hear about today. And that's the bottom line. As model intelligence increases, your starting line moves forward, and you could do more than ever before. We talk about the exponential a lot at Anthropic. You heard it a little bit from Ami as well. For me, the exponential means that as model intelligence increases, the use cases you can build and deliver to your users increases exponentially. For example, agentic coding is far more impactful than code autocomplete. And in this way, new products and new experiences create new markets and grow the pie for everyone. In research, we don't think about the exponential as sweet bench numbers going up. It's also about creating and tracking capabilities that previously didn't exist until we designed and created them. Tool use, computer use, thinking that adapts to the problem, agentic loops that hold a plan over hundreds or thousands of steps, and long context windows that teach Claude knowledge that it previously didn't have. And these capabilities don't just stop at code. Today, Claude can generate and iterate on visual designs, analyze and create complex work deliverables, and also navigate business domains you might be a part of in open-ended, ambiguous fashions. That's because the model intelligence, the core foundation, has gotten smart enough and strong enough to support all of this. When you're building on Claude, you're building on the model family that created these capabilities first and has had the most time to make them reliable. Let me make that concrete with our latest model, Opus 4.7. AMP, the coding agent, moved their entire smart mode onto Opus 4.7 because it scored the highest on their benchmarks, and they were able to simplify their tooling, change their scaffold, because the model no longer needed the help. Rakuten ran it on their benchmarks and resolved 3 times the number of production engineering tasks than they previously could. And finally, Intuos saw Opus 4.7 identify its own logical faults during the planning stage, figure out what was wrong, backtrack, resolve it, ultimately leading to faster and cleaner execution. The day after we launched Opus 4.7, we launched Claude Design by Anthropic Labs, one of my favorite launches this year. Already, people are building production interfaces with a combination of Claude Design and Claude Code. This is because Opus 4.7 has a real taste for visual design, the right nuances to show while adhering to your design principles. And we also hear from everyday users that people like to use Claude because it understands a full assignment and can figure out when to push back and question assumptions. At the same time, as each of us already know, having built on these systems, the models are unfinished and they're works in progress. They can still be stomped sometimes by very basic things and also lose the thread when you introduce a lot of context. That's what makes this exciting, and thanks for being on this journey with us. Here's a little about what we're working on and what's ahead. First, higher judgment and better quality code taste. This means versions of Claude that you can trust with complex, autonomous engineering work. Second, context windows that feel infinite when combined with high-quality memory, so it feels like you could do long-running tasks while getting better results. And finally, multi-agents coordination, powering teams of agents and instances of Claude that collaborate on big goals that are far too big for any single instance ever could. The way I think about progress and model intelligence is task horizon. which is a measure of how long a version of Claude or a model can work autonomously while improving on its deliverables and the quality of its work. Last time this year, models can work for minutes. Now, most of you and I probably have agents that are running for hours on end. And tomorrow, we'll have agents that are proactive, always on, and know what to work on without losing the thread. So, what do we as developers make of all of this? The exponential will keep improving, and you need to build for emerging capabilities, not just for today's versions of Claude. This is because new models would be far more capable than the ones we have access to today. It used to be that we have to build scaffolding to keep every version of Claude up. And now scaffolding is there to actually amplify model intelligence. You used to have to design complex iterative loops, give it the right tools, figure out how to do retries. And now all of that can be folded into the right thinking and the right execution right within the model. You are already seeing where this can go. Opeth Preview, Mythos, is the next point of that exponential, and it's not a small step. Therefore, how we all work with Model and Claude needs to change. Here are some things we think about at Anthropic. First, you need to design for the next version of Claude, not just the current one. We've seen countless times that the developers who win are the ones who optimize their architectures to absorb the next intelligence jump, not just today's incremental accuracy. This means maintaining and creating harder evals, building ambitious prototypes that you don't think might work today. Because that's how you'll notice when the exponential is improving and moving under you. That something that previously didn't work all of a sudden starts passing. That's a sign that you probably have something magical to give to your users that didn't work before. And here's what the teams that are getting the most out of Claude have figured out. Model upgrades are a business opportunity. The teams that are getting the most out of Claude models are the ones who make upgrade cheap. This is automated evals, simple scaffolding, and ambitious prototypes and uses of capabilities that others haven't imagined yet. We believe that the exponential on slide 1 is going to keep looking like that. As model intelligence increases, US developers have the chance to make a head start to experiment with building new use cases, creating exciting new products for your users, and ultimately creating new designs and markets, and ultimately growing the pie. Everything Caitlin and Angela are about to show you will give you the tooling to make all of this possible and come to life. Thank you so much for being here.
So model capabilities are on the exponential. But businesses are still operating on the linear. And so as a business, it's never been more important to make sure that you're really able to harness the power of that exponential. But what's stopping businesses from really snapping to that? Well, it really boils down to two key problems. The first one is getting the right outcomes. Getting the right outcomes is still too difficult, right? You have to be able to do a lot of prompt optimization, tool construction, harness engineering. There's still a lot of work that it takes to really steer the model to exactly where you need it to go.
That's right. And the second problem is you want to ship fast, but you want to ship scalably at the same time. Everyone in the tech space is moving insanely fast right now, and you've got to keep up. But to win, you need quality too. It's really easy to ship prototypes, but it's really hard to scale in production. So we've built the Claude platform to give you everything you need to get those great outcomes and to ship with speed and scale at the same time. The platform comes with API primitives that are tuned to Claude models. It gives you infrastructure to build and scale agentic systems. And it gives you controls to operate those systems.
That's right. So if we go back to our problem statements that we hear all the time from different businesses, one of the most common ones that Caitlin and I hear all the time is how much businesses need high intelligence, but of course, at lower cost. So one of the ways that we're solving this is with the advisor strategy. This is really easy to implement. All you have to do is update your tools array inside the Messages API. And what we're doing is that we're actually providing an agent architecture that splits execution from advising. So in execution, you can pick a smaller model. It will be a little cheaper. But then that small model, when it needs advice on what to do next, it can actually reach out to a bigger model for help.
Yeah, so in practice, this means you could use a Haiku or a Sonnet class model to execute, and Opus as an advisor. And when we ran this with Sonnet executing and Opus advising, we saw Sonnet perform way better than Sonnet alone. But more importantly, we saw Sonnet perform even more cheaply than Sonnet alone because Opus was able to advise it to get its work done better. A great example of this was Eve Legal. Eve Legal used the advisor strategy, and they told us they got frontier model quality at 5 times lower cost.
Yeah, and that's awesome. We love stuff like this because you can go ahead and use this in things like a freemium model. Right? When you offer these kinds of freemium experience to your users, you have to be conscious of the costs that you're going to incur, but obviously you want to make sure you have a good experience for them. It's also really great for areas where you have an extremely high volume amount of workloads, and of course you'd have to be a little conscious of your ROI. So that's all great, but what about speed and scale? Those two things that Caitlin mentioned to be really difficult to achieve at the same time. Well, most recently, we introduced Claude Managed Agents. Claude Managed Agents is an agentic harness that's paired with production-grade infrastructure. Teams are able to go from prototype to production in literally a matter of days. The teams that we've worked with have been able to ship literally 10 times faster with Managed Agents. Another great thing with Managed Agents that we love is that it bundles in a lot of the best practices out of the box. So for example, when you build an agent, one of the best practices that you want to make sure that you do is, of course, give it memory. That way, the agent persists user preferences, and it kind of remembers closer to what you want it to do every single session. It's a little difficult to build memory, and so this is an example of a best practice that we actually just bundle in out of the box, and it's automatically tuned for Claude. And we want to make sure that everyone hears this. When we do give you memory, that memory is ultimately yours. So you can take that and port it wherever you'd like.
So one of our favorite examples of someone who built on managed agents was Notion. Notion wanted to build for speed and scale at the same time, so they chose to build on managed agents. And they built the ability for you to fire off Claude agents directly within their product experience for long-running, complex, autonomous tasks.
Yeah, and we love that feature. That's super cool. All right, well, today we are upgrading Claude Managed Agents with 3 really powerful features. We're going to be introducing multi-agent orchestration so that you can actually create fleets of agents to solve really complex tasks. We're going to introduce outcomes, which allow you to specify exactly what success looks like, and then Claude will literally just iterate until it gets it done. And we're going to introduce dreaming, and this one we're really excited about. But with dreaming, Claude is actually able to self-learn. It's able to actually inspect over its previous sessions, figure out skills that it missed, lessons it should have learned, and actually apply those directly to memory on its own. But instead of just showing these talking about all of these with you, we're actually going to show you live what these things look like. So, Caitlin, let's do that.
Let's do it.
So Caitlin and I have been inspired by some of the announcements earlier today. There's greater API rate limits for Opus, and we've been hanging out with a particular space company for most recently. So we've been inspired to create a little startup of our own, a fictional one to be clear, called Lumara. And with Lumara, we decided, why don't we build agentic software that helps us autonomously land drones on the moon? And we really care about speed and scale at the same time, so obviously we are going to build this on Claude Managed Agents.
Exactly. So let's say we lined up our first customer, and this hypothetical first customer wants to land drones on the moon to mine for hypothetical materials. And this is a big, ambitious job, and despite all of our dreams, we're not actually aerospace engineers, so we're going to need really awesome agents to get this work done for us. So we're going to integrate all 3 of the new features that we just talked about. And we did this for our first customer, and I'm going to show you using the Claude API CLI how we actually set that up. So first things first, this is a big job, so we actually want multiple agents to help us get this work done. So I'm going to go ahead and show you the agents that we actually have set up for our customer. The first one, we have a commander agent, and really the commander agent's job is to make sure that this whole mission goes well. Then we've got a detector agent. And the detector agent's job is to make sure that we're actually finding the sites to land on that will have high-quality mining materials. And then we've got our navigator agent. And the navigator is making sure that we're landing our drones safely and flying them to their destination. So I'm going to go ahead and actually set up our commander to be a coordinator of the other two agents.
And when this is running, what's actually happening is that the commander is spinning up a session. And then for each of these sub-agents, they have their own independent threads so that they have independent context windows. This is a very intentional design, and we found that by doing this all together and then merging in all the results, we get better performance.
Exactly. So that's multi-agent. Let's go ahead and integrate outcomes. So the way outcomes work is we want to make sure that our customer, which has very specific criteria for what they want to accomplish, can define that criteria, and then we can provision a grader agent that actually makes sure we get that outcome. And so outcomes actually just start with a pretty simple Markdown file. So here you can see a Markdown file, again, really, really simple, and it just kind of outlines this criteria that shows us whether a run is successful. So we want our drones to touch down softly. We want them to land on clear ground. And pretty importantly, actually, we want to have enough fuel in reserve so that we can get our drones safely back to Earth. So in order to actually set out this rubric for our outcomes, I'm going to go ahead and send an event to our session that defines this rubric as our outcomes.
Yeah, and when this is running, like Caitlin mentioned, we actually create a separate grader. And this grader agent is evaluating across the session as to whether or not in each run we've actually met the rubric that was specified. Now, of course, it could one-shot this, but more likely than not, it probably needs to iterate over a couple sessions to do it. And as Caitlin has highlighted here, you can specify the max number of iterations you want to allow this to do.
So we've integrated multi-agent, we've integrated outcomes, and it's time to test. Our customer gave us some data on 6 hypothetical sites that they might want to land their drones on for us to run some simulation sessions and see what happens. So I'm going to pop over into Lumara's dashboard, where you can see that I ran a simulation against these 6 sites.
Yeah, and this is pretty good. I mean, this is a one-shot with our whole system. It's got the multi-agent architecture, it's got the outcomes feature integrated, and you can see here that it solved 4 out of 6 sites correctly. But clearly, it could have done a bit better on sites 3 and sites 4. And like any two good founders, we obviously want to hill climb on this system. And normally, hill climbing is a pretty difficult process. You have to put a lot of work together to go and do that. But we're going to show you how we are hill climbing on this with just dreaming.
Yeah, so we ran the simulation yesterday. We weren't quite happy with our results. And we came into the Claude Developer Console, into our dreaming interface. And you can see I can actually just hit this little button that says Dream, choose a memory store where a dreaming agent can go and look over all of those past simulation sessions and write its learning to memory so that all of our new sessions can actually reference those learnings in memory to do a better job. So I did this last night, and this is our dream that ran. And you can see that we wrote a bunch of stuff to memory, which is awesome. And crucially and most importantly, the agent actually chose to write a descent playbook so that all of our additional sessions that we run going forward will have this playbook to reference, including all sorts of heuristics from the different missions that it ran previously. This is like a really robust playbook of a whole bunch of information that we can go ahead and use. So this ran overnight last night, and I popped back into Lumara's dashboard this morning and ran a new simulation now that our system is upgraded.
And that's awesome. Right, we were able to actually hill climb and not regress on any of the ones that we cared about, but the 2 sites that could have improved have actually improved. And to hill climb on this, all we had to do was just have Caitlin press a button in the console called Dream. All right, awesome. Let's wrap up. And everything that we showed you here today live in this demo is available on the Claude platform for you all to build on. Multi-agent orchestration, outcomes, and dreaming are now making the Claude Managed Agents primitive so much more powerful so that you can use it to construct deep, powerful agentic systems that scale. Whether you're landing drones autonomously on the moon, or you're building the next big business, Claude Managed Agents is here to help you construct the agentic systems that you need and solve the problems that you're looking to solve. Now we'd love to pass it on to Kat and Boris, who will show you how Claude Code is making it even more fun to build as a developer.
Thank you. Angela and Caitlin just showed you how the Claude platform closes the gap between what models can do and what agents businesses ship. We have a related challenge on Claude Code. We also want to close the gap between model capabilities and what every developer can actually do with them. First, I just want to thank all of the developers here in this room. Thank you for trusting Claude Code on your production databases back when Sonnet 3.7 was our frontier model. And when our product was a bit rough around the edges. Your support is what makes our team so excited to come in every day and make Claude Code even better. Let's start with why Claude Code exists. Software development is being reinvented in real time. The mission of Claude Code is to close this gap between the great ideas that you all have and shipping a product to the market. And the way that we enable this is we build tools that elicit the frontier intelligence from our models, and we make them accessible to every builder. And we don't think of ourselves as having a finished roadmap for you. We think of ourselves more like mountaineers, kind of like climbing alongside you into terrain that none of us have explored before, learning together what works as we go. And we're growing with you. We're growing with increasing AI capabilities, and we're navigating these new challenges together. I still remember a year ago when I would give Claude Code a task, and I would carefully review every single edit it was trying to make, every single permission prompt, giving it really detailed feedback on what I liked and what I didn't, and just like holding its hand every step of the way until the result was good. I remember some of these tasks would be like 100, 200 permission prompts until I got the final result. And now most of you are running in auto mode. You're delegating permissions to Claude, and you're checking in after Claude has done a lot of its work and has a PR for you to review. Over the last year, we've expanded the number of ways that you can use Claude. We started with the terminal, then we launched the IDE, and now we have desktop. We started with the CLI. This is still the interface for power users who want a minimal text interface, who want all the latest customizations and the most control. Then we added IDE, because a lot of you actually want the same powerful agents, but you want to follow along with all the code changes that it's making. And then based on all of your feedback for something a bit more visual, we knew where we had to go next. We launched our newest surface, Claude Code on Desktop. It's a surface that's designed for people who want this like full-screen graphical interface, built-in preview so you can watch as Claude develops your app, a sidebar control plane for all your agents, and the ability to render images and rich outputs. We've built Desktop to be a control plane not only for your local sessions, but for your remote ones as well, with visual indicators for which agents are stuck and which ones are ready to go. The IDE and the desktop app are built on the Claude Agent SDK, the same SDK that many of you are already building on. Many enterprises have adopted Claude Code tools wall-to-wall. At Anthropic, this has driven a 200% increase in the number of PRs per engineer, while keeping the same code quality bar, even as our engineering team has scaled substantially. Together with you all, we're discovering and redefining the future of what software engineering looks like. We're embracing these new challenges by embracing automations powered by Claude to overcome each. I'm going to walk through a few of them right now. Here's the feedback that we heard from our users and what we've built with the help of this community. We heard from you that you want to spend less time on code review. So we shipped Code Review that deploys a team of agents to catch critical bugs on your behalf. Thousands of companies use this every day, including all internal Anthropic teams. We heard from you that you really want to code on the go. So we launched Remote Control, and we added Claude Code to the iOS and Android Claude apps so that you can fire off a task from anywhere. You're no longer walking around with an open laptop, balancing it, trying not to fall. And you're no longer stuck at your desk. You can now go to a park, touch grass, and still code. We heard that you're spending a lot of time babysitting PRs, fixing flaky CI tests, addressing code review comments, resolving all the merge conflicts. So we added AutoFix. It just listens to all these events, proactively puts up fixes so that your PRs are always green. We heard from you that you're kicking off Claude Code tasks on new tickets and new customer bug reports. So we thought we should build routines. So we have routines, and it lets you configure once, listen for webhooks, API events, or run on a schedule. And it'll just kick off Claude Code automatically for you. So instead of you having to manually kick things off, Claude will handle it. And last, we heard from you that you're launching so many features that your security teams are having a hard time keeping up. So we built Claude Security. It scans your whole code base overnight, and it can kick off Claude Code to address the vulnerabilities that it finds. All of these primitives compose together, and this helps all of us together adapt to the future of what engineering looks like. Everything I've covered is something that you can pick up today. It's been especially exciting to see how a range of companies have taken these tools and adopted them at the scale of entire orgs. First, I wanted to share about Shopify. They power e-commerce for millions of merchants worldwide, and they've imbued AI across the entire engineering org and changed their culture. They're using Claude Code across the company, both on engineering teams, but also non-engineering, so design, product, data science. They're building it directly into their platform and standing up tools at scale. Andrew McNamara is the director of applied AI at Shopify, and in his words, the speed is just crazy. Claude Code has completely transformed how they build internal tools. Another example is Mercado Libre. They're Latin America's most popular e-commerce platform. They serve over 100 million buyers. Their org is 23,000 engineers, and everyone runs on Claude Code. When that happens across an org, the work itself changes shape. Engineers are pointing agents at tech debt that people haven't touched in a long time and people don't have time for. It's reviewed more than 500,000 PRs with human oversight and modernized more than 9,000 apps. Oscar Mullen, who leads technology, is aiming for 90% autonomous coding and fully agent-driven PR loop by Q3 of this year. And we hear this from many others across the industry. The detail I love the most here actually isn't this number. It's that a lot of the managers and VPs we talk to are like getting their hands dirty in the code base again. Claude Code is putting coding back in the hands of people who've spent the last decades on roadmaps and reviews, and now they're back building. We see this across the industry. Millions of developers are getting more products shipped at a higher quality than before. Now, let's see what this actually looks like in practice. To take you through it, please welcome the head of Claude Code, Boris Cherny.
Thanks, Kat. Can we do a quick selfie? Phew, all right. Before I jump into this demo, I just want to mention something. Everything that we're showing today still feels magical to me, and I work on Claude Code every day. Even in Anthropic, we share screenshots back and forth of the cool things that people are building with Claude and things that people are doing in the wild. And honestly, I just feel excited to be on this journey together, discovering all of this. So today, I'm excited to share a few more examples of what this looks like. Unfortunately, we can't all work in the lunar drone business. So for this demo, let's imagine that we're an engineer at Acme Pay, and it's a payments infrastructure company. We're going to start the Claude desktop app, and we're going to start by working on a single task. In this session, Claude's working on adding refunds to Acme's merchant dashboard. It's building a full implementation. Idempotency, so a duplicate webhook doesn't double refund a merchant. There's multi-currency handling across all the regions Acme serves, and audit logging for the compliance team. It writes the implementation, and it's going to verify its own work. Claude pulls up the merchant dashboard. It triggers a refund. And there's no success toast. That's a real edge case. Claude sees the failure. It traces it back to a race condition in the optimistic update. It fixes it. And it's going to verify that it actually works in a browser before it calls the task done. Now, let's zoom out. This session wasn't running alone. It's actually one of many sessions that were all running in parallel and being managed in parallel. In the Claude desktop app, you can now see all your Claude Code sessions, which ones are running, which ones need your input, and which have PRs that have already been merged and closed. Synchronous coding is now just a slice of what's happening at any given moment. And we think that going forward, a lot more code is going to start to be written in an async way. And this is why we keep talking about verification. If Claude can check its work, you can just let it run while you work on something else, and you come back to a fully working result. And for me personally, a lot of my code nowadays is written by routines. I'm not the one doing the prompting. I'm the one creating a routine that does the prompting. For engineers in the room, think of it like a higher order function. Routines are a higher order prompt. For example, the refund session that we just looked at. A teammate filed a GitHub issue overnight. A routine watching the repo picked it up async and then kicked off the work in Claude. With routines, developers can set up async automations and wake up to PRs that are ready to merge. Here's our routines view. Routines can be run on a schedule. They can be kicked off by webhooks, or they can even be kicked off by arbitrary API calls. You can run them locally on your machine or on remote cloud compute. Let's look at one more feature. This is CI autofix that Kat talked about earlier. And what it's doing is it's watching the PR the prior session just opened. Its job is to babysit the PR to get it all the way to production. It's going to autofix any comments from code review and security review. It's going to autofix CI, and it's going to auto-rebase if there's merge conflicts. And look at what just happened. CI flaked on a network timeout. The routine woke up. It diagnosed it as a known infra issue. It retried the job, and now it's green. And actually, in the Claude code base, we have it not just retry, we have it fix the root cause every time. The engineer who owns the PR is never going to see a red X, and that work is off their plate. And that's the shift. The default isn't, I'm going to prompt Claude code. The default is now, I will have Claude prompt Claude code. Everything you just saw is available today, including routines, the latest updates to the Claude desktop app. We're excited for you to try it out and let us know what you think. We hope these features continue to close the gap between your ideas and shipping products. And that's really what every talk today was pointing out. Diane's capability curve, Angela and Caitlin's agents that grade and improve themselves, what Kat and I just showed you. These are 3 layers of one story. The capability is already here. The gap left is how fast we put it to work. I encourage you to spend the rest of today exploring these layers. Research talks if you're evaluating the models, Claude platform sessions if you're building for your users, or Claude Code workshops if you want to learn more ways to bring Claude into your day-to-day development work. Dive in, go deep, and start building with us. Thank you.
please welcome to the stage member of technical staff of Anthropic, Dixon Tsai.
All right. Good morning, everyone. I'm Dixon from the Cloud Code team. I work on plugins and Cloud Code on the web. This session is about what's new in Cloud Code. If you've seen our public changelog recently, you'll know that our team ships a lot. It could be kind of hard to keep up. So today, I want to step back from the changelog and give you the story, how our new features fit together and why we love them. Our new features fall into two themes. There we go. Our new features fall into two themes. First, developer experience. How we're making Cloud Code nicer to live in as you spend more of your day with it. Second, autonomy. How we're enabling Claude to do more while you're away from your keyboard. Finally, I'll cover how to learn more for everything I don't get to. As daily users of Cloud Code, we're still very invested in the human experience, even as Claude can handle more long-running tasks on its own. For developer experience, first up is remote control. Remote control lets you start a session on your machine and pick it up on the go. From your phone, you can access the same session, same dev setup. Why not kick off a long-running task and run some errands? We wanted more convenience on our team when building Cloud Code, and remote control gives us that. Let me show you how to set up remote control with a demo. All right, so we are in a new session. Let's just seed it with some content. And now we can enable remote control by typing remote control. What you get is a link in Cloud Code on the web. So let's open that and put these side by side. And you can see the content of your terminal online. And from, this can be your mobile browser. This can be your mobile app. You can type 3+3 or something like that, and it'll appear in the terminal. Same dev setup that's running in your terminal. You can also type in your terminal and see it in Cloud Code on the web. So my favorite pattern here is to enable remote control on a long-running session that has accumulated context over multiple PRs. That way, when I'm on the go, I can ask that long-running session to spin up a sub-agent and get my idea implemented. Back to the slides. Next is flicker-free rendering. Show of hands, how many of you have encountered flickering at some point when using Cloud Code? Woo! That's how you know that you're an OG. So we've heard from you loud and clear that flickering ruins the terminal experience. Our previous approach of appending to the existing terminal scrollback was tricky to get right. One misalignment could trigger repainting that would cause the flickering that you see. Now, Cloud Code's terminal UI has full screen mode, where we virtualize scrollback. By doing so, we can guarantee flicker-free output. On top of that, we can make elements of Cloud Code in the terminal clickable. And we can keep memory usage flat, even for very long sessions. Our team has switched to this for the most part, and you'll feel the difference immediately if you do as well. Let me show you how to use it in a demo. So in a new session, I'll expand this. You can enable full screen mode by saying TUI full screen. TUI is short for terminal UI. By the way, did you know that there's a voice mode in Cloud Code? How many of you have used voice mode already? OK, a fair number of you. You can toggle it on or off by using /voice. And now you can hold the space bar to say a prompt. So I'll say, write me a file containing 10 jokes and another file containing 10 fun facts. Containing 10, there we go. All right, so as Claude is working, you'll see how smooth the rendering is for full screen mode. Even for very long content, you don't see any rendering artifacts. And one thing you can do is for these tool calls that are folded, you can expand them with a single click. Now, let me show you how virtualized scrolling works with another prompt. Create a file containing 10 career tips. Career tips. OK, there we go. And as it's working, let's say you are scrolling back and reviewing the existing output. We see this jump to bottom here that you can click, and our existing prompt does its processing and has alerted us that there's a new message. So it doesn't affect your view above the transcript, so we can then jump down and see what that new message is. This is full screen mode. So if you're like me and you spend a lot of time in the terminal, full screen mode provides you a really smooth, intuitive experience. Back to the slides. Some engineers on our team prefer the terminal, but others are increasingly using the Claude Code GUI across desktop and web. We've revamped the GUI into a much better experience for managing, 1, multiple sessions at once, and 2, presenting all of the relevant context you need for the session so that you can work more efficiently. Let's take a look at some of these new features in a demo. This demo is based on Excalidraw. So Excalidraw is an open source whiteboarding app, and the original experience has 3 basic shapes: rectangles, diamonds, and ellipses. But let's say I wanted to draw trapezoids. Well, I have a Claude Code desktop session cooking with this with this feature. If you haven't seen Claude Code Desktop in a while, a lot has changed. In the sidebar, we have a pinned section and also more advanced filtering and grouping capabilities. In fact, you can group by your project, for example. From the sidebar, you can also open up a split view, just like that, with drag and drop. On the top right corner, you can see a lot of views for your session, because the transcript's kind of boring sometimes, right? You can open the plan corresponding to this session. You can even highlight certain parts to leave comments, and all the comments can get aggregated and resolved by Claude later. So in addition to the plan, you can open a diff view and also leave comments on any line. Finally, if you're kind of lost, you can open the files view where you have your entire working directory, and you can also make edits really quickly. But what we're betting here is that you're spending more and more of your time with Claude as Claude becomes more capable, and all these functionalities are more optional, right? They're not your default experience. They're just something you grab onto when you need them. Now, let me show you this really cool experimental feature. So you know that this transcript is really long. Now, one thing we can do is we can hover over an assistant message, and there's a Pin as Chapter button. You should try to guess what this does. So let me click here. And then you can see that above this assistant message, we now have a title for this message in the context of this transcript. You can rename this title, debug pointer down event. Let's maybe add one more. How about this one? So we'll pin this as a chapter 2 and see what its title is. The title is Add Missing Distance to Trapezoid Element Function. Cool. So we now have 2 titles. What can we build with this? We can build a table of contents. So now in the top left corner, you can jump between different parts of your transcript. You can rename these chapter titles, or you can even delete them if you want. So that's an experimental feature, and we think that we can make a lot more in Claude Code Desktop. Just let Anthony Morris, our Claude Code Desktop lead, know on X, and he'll probably ship it for you tomorrow. So one last thing here is we haven't looked at trapezoids, so let's actually run a server. We can open up the terminal right here, start the server, It's going to run in localhost 3002. And now you can draw trapezoids, and you can even make them orange. All right, let's go back to the slides. So that's for developer experience. Now onto our second theme, autonomy. Each of these next features came from the same place. I'd hand Claude something long-running and one small thing, a permission prompt, a branch conflict, a forgotten build command, would lead me to wonder, Claude, why'd you do that, when I come back to my laptop? The features I'll cover next will give you more confidence that Claude will do what you want when you step away. First feature I'll cover, show of hands. How many of you have become tired of permission prompts? Where you go 1, 1, 1. You can probably start a wave, right? With your hands. Auto mode is a new permissions mode in Claude Code where Claude makes permission decisions on your behalf using a classifier. So when you have a tool call that would otherwise hit a permission prompt, the classifier will look for two things. One, is the action destructive? And two, does it look like prompt injection? If the classifier determines the tool call is safe, it just lets it run. If not, then Claude will block the tool call, and the agent will have to figure out what to do next. This has saved us a bunch of time at Anthropic and helps us eliminate the number of instances where we thought we started a long-running task just to come back and be like, ugh, a permission prompt. So next is work trees. Next pain point is how do we work with multiple features without your Claude stepping on each other? Work trees are my favorite feature because they've helped me overcome this pain. Git work trees have existed long before Claude Code, where it will create a new branch and it will copy all the files of your repo. But there are so many sharp edges. And so we've taken the time to think about what those edges are and to smooth them out into a friendlier interface for us and for Claude. So for instance, we've integrated in Claude Code settings a field where you can declare the files that should be shared across your work trees, like node modules. So then, if you wanted to start a new session, you can just use --worktree, and that new session will be accompanied by a new work tree. Or you can ask Claude to create a work tree for you. Let's take a look at this in a demo. So again, our demo is based on Excalidraw. In the original experience, you see here we're going to add two things for our demo. One is we're going to add a new color. And two, we're going to add a slider to help us make these corners more round. So we're going to start a work tree by using Claude-W, which is short for --worktree. So we have a work tree for colors, a work tree for border radius, and I'm just going to write in the prompt right now, add a sixth color to stroke/background. And then for this work tree, I'm going to say add a slider to adjust border radius. All right, so as these two sessions are cooking their respective features, let me show you how Claude can create work trees on its own. So I can say, for instance, create a work tree to add a star shape. And so it's not just --worktree. We've actually given Claude an enter worktree and exit worktree tool, so Claude can determine for itself whether it should start implementing a new feature in an isolated environment. So you can see that Claude has created a worktree. I'm being explicit in this demo, but you can put this prompt in your Claude MD. You don't have to be as explicit. Claude will know what your intent is. Okay? And Claude is polite enough to ask me when to start implementing. I'll actually say just leave the work tree. And you can see that our harness cleans up the work tree for you. So it's very convenient. And that way you can have a long-running session that works on many different PRs simultaneously. Okay? So let's take a look at our features now. Looks like the colors are ready, so let's run yarn start in the background and tell me the port. The other feature is still working. So this will take a little moment. All right, so this is ready in localhost 3003. And you can see I still have the original experience running on my main checkout of Excalidraw. This new experience has the sixth color. So this feature, the agent was working independently on this feature. And then we can see how this other one is doing. It's still working, but I think you get the idea. Work trees are just super convenient for launching multiple agents to work on multiple features. Back to the project preferences. And Claude will decide what's worth remembering based on whether the information could be useful for a future conversation. In particular, Claude, for every project, will manage a directory. And within the directory is a memory.md file. It's an index file that gets included in your conversation, just like Claude.md, but it's exclusively managed by Claude. And from this index file, it can offer more files to, it can link to other files in the same directory that have more details. So we leverage progressive disclosure, much like skills. So this feature is very handy. It also works for subagents. So if you have a custom subagent, you can say memory user or memory project to establish a memory directory. And this feature wouldn't be possible without recent breakthroughs in model development. So compared to Opus 4, Opus 4.7 and other recent models are more capable of managing its memory as a set of files in a directory. So if you've been following along, Claude's been doing much better at Pokemon because of this capability. Next up is code review. At Anthropic, we have discovered a more effective code review pattern that's multi-phase and multi-agent. Spin up a team of reviewers to look at independent aspects of your code, then verify that the findings are actually worth reporting. This process catches issues that would have otherwise taken you hours or that you would have missed altogether. So you can set up this code review for all of your PRs through our GitHub app, or you can try it out manually in Claude Code by using /ultra-review. So between auto mode, work trees, auto memory, and code review, you now have fewer actions to approve, more agents safely working in parallel, sessions accumulating knowledge over time, and teams of Claude reviewing changes all before you yourself have to look at each PR. Your time is valuable, and we should leverage Claude's ability to make the most of your time. All right, and that brings us to the final feature we're covering today, routines. Routines have shipped in research preview recently, and they help you create sessions in Claude Code that can trigger without your intervention. So we've talked about how we have features that help the agents work more autonomously from idea to PR, and now we're automating the idea generation itself, right? The shape of a routine is simple. You configure them once with your prompt, your repo, and relevant connectors, and then you can select a trigger, either a cron schedule, something that runs hourly or daily, a GitHub webhook event, or you can even set up an API endpoint that you hit for the routine to run. From there, Claude runs without you. So you can have a routine that triages GitHub issues every day. And then if you enable the Slack connector, you can have it send a digest of those top issues to Slack. Or you can have a routine that gets run every time your e-commerce website earns a sale, right? You can have Claude be happy with you as well. So let's see how routines work with a demo. Now, routines are a feature that is very prominent now in the sidebar, but we also introduced /loop. So let's start a new session. What we can say is /loop 1 minute, tell me a joke, for instance. And then I can use my backup side by side. So, split view is kind of nice. So /loop can help you set up automation within a single Claude Code session. So Claude has a cron create tool, similar to the enter worktree tool, where it can, at its discretion, start a scheduled job for you. And of course, you can always disable this tool in your settings if you don't like it. So now I've had it schedule tell me a joke every minute. And so there's a joke about why programmers prefer dark mode, because light attracts bugs, et cetera, et cetera. OK, so compare this against routines, where you can kick off a new routine either locally on your desktop or remotely. I prefer remote because if you set up a routine locally, you have to have your laptop open. But if you run it remotely, our servers will schedule and run these jobs for you. In fact, I have my own routine I've been running a lot recently. Let's walk through it. So my instructions here are scan the latest open public GitHub issues with the most Reacts created since the day before. Look only at the issues with labels and area plugins and area hooks, which I'm responsible for, and respond with a separate list of the top 10 issues sorted by the most Reacts. And so it's been running for a week now, and you can see that every day I get a really nice report of the top issues, and I don't have to think about prompting Claude to launch these reports. And you can imagine we can set up other automation to then ingest these reports, launch subagents to fix them, et cetera. OK, let's go back to our jokes. So once we're done, writing jokes, we can say stop the loop. And Claude can interpret your prompt, map it to the proper tool call, and delete it. So you'll also notice that we have a tool search tool now. What tool search does is it adds a layer of indirection between you and the actual tool definitions. So now we can offer more tools at once without directly impacting your context. All right? Back to the slides. So we've covered developer experience. We covered autonomy. Now let's go through all the other items that I couldn't get to in this conversation. You can take a picture, or you can just get a sense of the overwhelming number of features our team ships every day. In particular, for those of you managing Claude Code for your team or enterprise, we've built some features for you. For example, we have much better Windows support than we've had months before. We have cloud provider setup, native installation, admin settings management, and plugin features for company-wide harness improvements. As always, you can follow along in our public changelog. Beyond the changelog, we have a few ways to keep up with what's new. You can follow Claude Devs on X. You can read our weekly What's New digests in our documentation. Or you can subscribe to our developer newsletter. We hope you get a chance to try at least one of the features that we covered today and let us know what you think. And then, for those of you in the room with us, we'll be having a conversation with Dario and Daniela, moderated by Ami, right here on the main stage at 1 p.m. Thank you very much, everyone.
Please welcome to the stage Chief Product Officer of GitHub, Mario Rodriguez. Please welcome to the stage Chief Product Officer of
people in Flow. They want to keep developers in Flow. They want their teams to gain velocity. They want teams to actually achieve more with the people that they have. And they want to do this at scale. And to be able to do it at scale, you have to have efficiency, and you also have to have trust. And I start with this because almost every single product decision that I make kind of is grounded on these pillars. Even when we actually talk about the platform and integrating with our cloud platform, I want to make sure that I keep developers in Flow. I want to make sure that teams gain that velocity, and I want to make sure that the companies can do that with intelligence and trust. Now, as I think about it forward, and I was thinking really hard, okay, like what do I want to say here? If I was sitting there, what I would like to understand is, okay, how do you operate, we do billions and billions, probably over a big enough time size, trillions of messages against the platform. So I wanted to kind of give you the best practices, or maybe not even best practices, because things change so often, almost on a weekly basis, but kind of like the key learnings, the things that are at the bottom of almost all the decisions that we make to be able to integrate with the platform and achieve that scale and that efficiency that is necessary. So I'm going to divide it into 3 things. Number 1 is prompt caching. Without that, we're not dead, but oh my God. Like the amount of money that we would spend compared to what we do, it's incredible, right? So just 1% efficiency on this means a lot to us. It's kind of like high-frequency trading. Just 1% efficiency means millions overall. So I just want to spend a little bit more into how we're doing that. The second thing is we're collaborating with Anthropic on capabilities to make sure that our customers are using the right inference, the right amount of intelligence at the right time. And then one of those is this advisor model. And we have 2 ways of looking at it, both through an advisor and a critic. So Brad and I will share a little bit more about that too. And then the third one is, okay, every time a new model drops, and if you're integrating with the platform, you know that this happens constantly, and you get a call at 5 a.m. on a Saturday, it's like, hey, we're launching on Tuesday. So how do we actually go through that the right way? How do we make decisions like what is the default model to keep developers in Flow? And how do we make then decisions to actually route to the right intelligence at the right time overall? So I'll start with this, and this is a dashboard. This is not our dashboard, but if you are on top of the platform, I believe Anthropic released this last week. We got a little bit preview of it. And what it allows you to understand is how are you doing, like your cache hit ratios, how many messages you're sending against Messages API, right? And I think this is great. This is the first step, because without data, it's really, really hard to make decisions. Really, really hard. So if you haven't checked it out, please do so. Now, the one that I want to spend a little bit more time on, it's ours. And this is just one, this is not the entirety of all of our dashboards that we have, but it's one where we take a look at deltas between models. In this case, I want you to look mainly at the left-hand side, that's Opus 4.6, and then on the right is 4.7, and then the next column is the delta between them. So when a new model drops, and sometimes we get it in EAP, we go ahead and run a set of benchmarks against it. So think about Terminal Benchmark 2, and then, or one of the suite, we have our own ones as well. And then we try to decide, okay, how is the model performing? And then we ship it, and then we pay attention to that data again. And then after a period probably of 30 days, we're probably done, or maybe sometimes even sooner, we're done with all of the optimizations for that model. Now, you can see over here kind of the median cache tokens, and at the end, the cache rate. For us to operate the service at scale, we need to run above 94, usually 94, 95, 96%. If we operate at 70%, that means usually that we have a bug, believe it or not. Like we're doing something not right, and then we need to change the approach on how we're calling the model, how we're assembling the prompt, how we're doing the end-to-end to keep that developer in Flow. So we pay attention a lot to that. The same thing, if I want to actually change the cache rate from, change the default model from 4.6 to 4.7, I need to understand what's the cash rate difference and what it actually means to me. Again, we make billions and billions of calls overall. So just 1% in that, in this case it's 1.3%, means a lot to us. Now, you also have to take into account that from an input perspective, your cash rate is only 10% of the cost, right? So it's a 10x difference in there. So if you're constantly invalidating that cash, that is not a very good thing overall, because you're going to be paying 10x more. And then we kind of go across it. In this case, we did a baseline against 4.6 on it, and then also on HiQ. Now, imagine it stays like this for a second, and there's a bunch of red, as you can see in this screen overall. Then we have a decision to make. We have a decision to make to try to figure out how to get all of those reds into green. And it's not luck, it's a lot of hard work. And I want to make sure you understand that. It's a lot of hard work to get it, maybe from 50 to 70% it's not, because you just kind of easy hanging fruit. But from 70 to 80, from 80 to 90, and 90 and above, there's a lot of hard work that goes into this and engineering. And there's 3 things that we take a look at. Number 1 is we make sure that there's no, and these are lessons learned. Like, we have made these mistakes before, and that's why I wanted to share it with you. We put no dynamic content in the prefix, right? Like, you need to keep that prefix as static as possible. And as an example, at one moment we had UUIDs in the actual system prompt, and then we're getting constantly reset, and then that was invalidating the entirety of the cache rate. So remember, system, then there's tools, then there's the conversation, and then there's the last message that you're sending. That's kind of the hierarchy. So you want to keep that system prompt as stable as humanly possible. No dynamic content on it. Then goes tools. We made a lot of mistakes in tools at times. If you're actually loading tools dynamically and you're changing that tools prefix, then all of a sudden everything, the entire conversation gets invalidated again. So you have to do work, and you have to make sure you have a lot of regression tests, because you're going to be experimenting a lot with what? Skills and tools overall in your end-to-end. You have to have regression tests to make sure that you're not affecting your tools. And then the third thing then overall is that we need to have that cache affinity. And let me tell you, it's really hard when you're doing a multimodal harness. So take, for example, Copilot. The customer can be calling, let's say, Opus, then calling a GPT model, and then going to an OSS model, and then coming back into Opus again. And then through all of that, I have to make sure that the next Opus call, that last one that happened, actually has the right cache affinity too. So we do a lot of work when it comes into our multimodal harness to make sure that that is guaranteed. So, the next slide. So here's an example on something that we ran, in also to debunk a myth. So one of the key things that I heard many times, actually when I go to customers and they ask me about integrating with the platform is, hey, does long context mean that it's more expensive? And the answer to us is no. And this is a quick test that we ended up running. So there's a smaller context window, and you could see in there that my average compaction went up 3 times compared to a largest context window. This was something that we simulated. We kept the same model with the same context window. We just ended up doing more compaction on it and filling it at a rate. Now, the key thing over here, if you remember the math of how many input and output tokens ends up happening is 5x, right? So for Opus, it would be $5, $25 as an example. In that case, whenever you do compaction, you get 4,000 tokens of output, and then because you have to summarize the message, et cetera, et cetera. So whenever that happens, then you end up usually paying more because you end up doing a lot more compaction, which means that your output tokens go through the roof, and then your cache rate also gets a little bit more invalidated because of that too. Well, significantly invalidated because of that too. So longer context windows does not mean you're spending more. In fact, what you have to understand is how compaction is being done, and depending on the scenario, you want to manage that for the user appropriately. So, and that's good. All right, so at a high level then, instrument your cache risk rate, have a dashboard that actually shows it to you, invest the time to do it. They're already shipping one for you, so at the very least use that one. But go and invest in deltas, go and invest in pre the model launch and then post the model launch as well. Now, no other efficiency matters until you see that one again. Like you want to be driving that from 50, 70, 90s overall, and it will take a lot of hard work, a lot of engineering time. And then you want to measure per surface. We have VS Code, which is one of the dashboards that we show you there, but we also have the Copilot CLI. We also have our coding agent in the cloud. We also have IntelliJ, and we have mobile too. So it's a lot of surfaces that you're going to have to go and understand, either share the hardness across them or then tweak individually. So you want to have a very good kind of sense of we shipped something, we regressed or not. We shipped something, we improved or not. Now, another thing that I was telling you about is, okay, if you got prompt caching already done, what about making sure that the right intelligence hits the user at the right time? And for that, Anthropic and us have been partnering on this advisor model. And what I want to do is bring Brad Adams from the Anthropic team to talk more about it. Go ahead. Brad?
Thank you, Mario. Oh, hey. Thank you, Mario, for being here. It's so great to have a partner like GitHub Copilot. The Copilot team gives such great feedback. We give them very little time to evaluate models before we launch, and they give great, insightful feedback. And it's true on our API features as well. In fact, if you're using the Claude platform, a lot of what you're seeing is thanks to the things Mario and his team are doing on Copilot. And it's actually one of those pieces of feedback that I want to talk about today. One of the pieces of feedback we got from the Copilot team is they really wanted Opus-level intelligence, but it's at Haiku-level prices. That sounds like a good deal, right? Opus intelligence. So I don't get to write the deals, but what I do get to do is build fun API features. So I want to talk about the advisor strategy. And really, the insight on the advisor strategy comes from software development teams. We all know if you take a junior engineer and you give them a mentor who's a senior engineer, that junior engineer gets a lot better because the senior engineer looks over their shoulders, they review code, they look at design docs together. The senior engineer can make the junior engineer a lot more productive without taking too much time from the senior engineer. And it turns out the same thing is true for models. You can take a junior model like Haiku, who we're listing here as the executor, and give it access to Opus. And you can very conservatively use those Opus tokens. So in this beautiful diagram that Claude created for me, what you see is the executor, Haiku, is able to identify every shape as it comes in, no problem, except for one little weird shape. That weird shape, it's beyond what Haiku can do. So Haiku has a tool. It calls the advisor. It calls Opus. Opus then, because it's a bigger model, it does more reasoning, and it knows that. And what we see from this in our evals is that we get close to Opus-level intelligence at much lower prices because we're being very conservative about the tokens that advisor actually sends. And because of the price difference between the two, it works out really well. And what I'm excited about is an integration that we work with the Copilot team. So let's switch over to the demo machine. Let's switch over to the demo machine. And what you're seeing is GitHub Copilot. On the left-hand side, it's just GitHub Copilot with Haiku. And on the right-hand side, you're seeing GitHub Copilot with Haiku plus the new advisor tool hooked up. So I'm going to hit enter here to give this time to run. And there's a little kind of brain teasery problem here that it has to solve. It has to give it the exact same problem. And we see Haiku is taken off. Whereas on the right-hand side is Consulting Advisor, so it's going a little bit slowly. So I'm keeping my fingers crossed here that Opus will come back. And so on the left-hand side, Haiku is just spinning away, trying a bunch of things, just like you would see a junior engineer who's very eager, trying lots of things, but hasn't found it yet. On the right side, the Opus advisor just returned, and because it's Opus, it actually knows this bit of data, and so it's able to bring that back into context. And now we're done with Opus, and everything's still in Haiku, but because it got that little bit of hint, the right-hand side has finished here. So we see it, the right-hand side finished. The left is still trying to figure out which way is up here. So just that little bit of hint from Opus, very small cost, very small latency hit makes Haiku so much more powerful. So this is an experiment we're doing in the GitHub Copilot CLI that we'll release soon, and looking forward to you playing with it. Thank you, and welcome back, Mario.
Thank you, thank you. I love some Opus Intelligence at Haiku prices. That's kind of what we got to do. OK, so what we show you is an advisor model. There's another algorithm that you could actually employ as well as you're tinkering more how to get the right call to the right intelligence. And we call, we're GitHub, we're a little bit weird on some of the things. We call it Rubber Duck. And what Rubber Duck is really all about, and here's a demo I'm going to show you in a second, it's really about inserting a critique at the right moments in time. So I have a feature. That feature, it had an issue, and over here I'm implementing it at the moment. And what I want to highlight, and it's going to come really soon, is the model now is asking for a critique. And you can see how it's asking for a critique from 4.6 and 4.5 Opus. Then it receives that critique, and then it's able to actually change the plan prior to implementation, and then continue with that implementation the right way. And then we get that feature and we deploy it. So that's very, very quick, but really what I wanted to highlight is a different model. It's a different model that acts less as an advisor and more as a critique on, hey, here's what I think you should do. And we insert this in 3 core places. One of them is after drafting a plan. We have a lot of our users that do a plan first, and then after drafting that plan, they go into execution. We have another one after a complex implementation. So think about it. I just finished all of this. Go and critique. It's kind of like a pre-code review to a degree. And we do it sometimes there because it ends up saving tokens then to wait all the way into an official code review as well. And then the other one is after writing tests, but before running them. And in certain places where your CI suite with tests takes a significant amount of time, then you can see how that at the end gets you to that flow faster, and it keeps that developer in flow. So those are the 3 places that we're doing it right now. And from my end, what I really have seen work well is kind of at the plan phase. Like a lot of these systems are getting really, really good at planning. And then if you catch it there, then you end up with the most gains post as well. Now, Rubber Duck is already an experimental. So if you download the Copilot CLI and you enable that experiments, you're going to see it there. And you could invoke it whenever you want. So you could just say, hey, create a plan on this and consult with Rubber Duck. And then you get a quick critique across model families as well. Now, let's continue moving. The third thing that we wanted to talk about is, OK, how do we, at scale, take new models? Like, what is the process that we do? At the very beginning, it was messy for us. But since over the last kind of 2.5 years, we've done a lot of work to make sure we're very methodological about how we take this model. So you can see Anthropic has a model to try. We onboard that model into what we call CAPI, which is our Copilot API. And then we have an endpoint. And then from that endpoint, 3 things really need to happen. Number one, as you all know, you have to go ahead and work in the harness and work in your prompts. So for us, we have a multi-model harness, right? So it's not just one model family. So we have to go over there and make sure that we update the system prompts. We partnered very, very closely with Anthropic on that. We have to then make sure the tool interfaces are right and optimized. We then have to, and we don't do this anymore as much, but we have to tweak the agent loop a little bit. And then a lot more work goes into context management, into compaction, into making sure that we're hitting the right cache hit rates overall. Then from there, we do 2 things. We run offline benchmarks, and then we also do internal dogfooding. Think of that as online benchmarks overall. So a lot of the Microsoft developers use it, a lot of GitHub developers use it, and we have a set of other users that we kind of partner very closely with as well to give us feedback. So we have that offline, and then we have that internal dogfooding. Then from there, we share findings with Anthropic. And this is a presentation. Before we used to write a document. Now we write a document and kind of expand it in detail, where we're like, this is everything that we're seeing. And then we go on a loop with them on changes that we need either at the API or even changes on some of those models as well, and the checkpoints that we end up getting. And then from there, we kind of do another loop all the way until the release of the model. Now, it's very important, two things. Like, yes, we do offline, and offline gives you an indication, but I would say it's not going to be at times reality. You learn a lot more from your online evals overall and the online experiments after launch than really the offline. Offline just kind of sets a base, and if that base is consistent, you kind of know what to expect out there, and it gives you a pretty good indication of that, of what to expect. But all of the details do not get done through offline. So it takes us usually days or sometimes even weeks to tune everything of that model out through those online experiments. We do a lot of A/B testing, and we're very methodological about that. And we do weekly reporting that we report up to Anthropic and also across the entirety of the teams that we have to make sure that we are tuning up the right model at the right time. So when it comes to optimizing the hardness for us, there are kind of four things. One is there's the build prompt and context. There's calling the model, as you say, executing the tool, and then appending the results and pull back and loop back. In what I was saying here, the places where I spend the most time with the team is usually in the execute tool and that build prompt and context. Tools are very important to us. The more tools you have, then the more confusion ends up happening, the more you have to tune. So hundreds and hundreds of tools is not a good thing. So you want to make sure you're tuning by surface and you're tuning for the exact scenarios with the right tools in that package. So we spend a lot of time in there and optimizing that model. And then the check permissions and then run. We end up, again, in that execution of the tool, you have to do the right things to pass the right context on it, and then to read the right results overall. So whenever we want to introduce a new tool, as an example, we spend a lot of time making sure that we're optimizing the hardness both at the model level and at the tool execution level. Okay, so what does this mean at a high level? There's two things. You have to go in and have both published benchmark, internal benchmark, but more importantly, dog food with A and B, and make sure that you have online evals set up. And make sure you could trust them with Stat6 as well. Then the second thing is, you want to measure outcomes, not activity. When I talked about the tools, like, as an example, acceptance rate on a code line, that's okay. Survival rate is actually an even better metric overall, because if you ended up accepting it and then you ended up deleting it after, well, that actually did not accomplish the outcome overall. So even though I could have an amazing acceptance rate, if the survival rate ends up being very low, that means that we did not do the right work. So it's very important if you're in product, and product really changes in the era of AI, that you're optimizing for the outcomes and not just the individual rows. Like I said, you end up then optimizing for a metric that then tanks the measurement of your entire product. Okay, so then with that, again, we walk through prompt caching, the advisor strategy, and then we talk a little bit about measurement and how we improve the hardness. And then for us, I just want to leave you and say thank you. Really excited again to be with you, and hopefully you learned a couple of things today.
Please welcome to the stage members of technical staff of Anthropic, Jess Yan and Lance Martin.
Hey everyone, hope everyone's having a great time at Code with Claude. I'm Jess Yan, product for Claude Managed Agents.
I'm Lance Martin, DevX team, and I do whatever Jess tells me.
That's news to me.
Okay.
But today we have a great agenda for you guys. First, we'll be starting with the AI exponential and how that has materially changed agentic development. We'll talk about the motivations for why we built Claude Managed Agents, a deep dive into the primitives, a couple of demos to bring some sizzle to life, and then we'll walk you through our getting started resources so that you can start building some agents of your own. All right, so we're all familiar with how our model capabilities are increasing exponentially. But as these capabilities increase, so do the task horizons and the complexity of the work that we're delegating to our agents. We're seeing that the bottleneck is increasingly infrastructure and not intelligence. So a couple years ago, you might have had Opus write and test a single component. You might be testing a flaky test suite. And this would be minutes, maybe an hour of focused work. You'd be steering it heavily along the way, and you'd be correcting it as it went off course. More recently, with our latest models, we're seeing that people are running things overnight, walking away, waking up the next morning, and seeing that their entire linear backlog has been resolved by an agent. In the not-too-distant future, we might see agents take on work that historically took quarters of teams working on it. Multi-agent coordinated teams will be running a full M&A pipeline end-to-end. And as tasks evolve from prompts to hours and hours and days of work, we need not just prompting scaffolding, but a true agentic runtime.
That's right. With managed agents, one of the main things we solved is reliability and security. So with long horizon tasks, these become much greater issues. You have an agent that's working for hours, weeks, or days, and need to be reliable. You also need to be secure. And also, new interaction modes become possible when you have agents working over long time horizons. So for example, with chatbots, it's pretty instantaneous or short horizon interactions. Long horizon agents require something that we call outcome-oriented tasks. So you give an agent a task and an outcome, like a rubric that indicates what completion means. We also need the ability for agents to stop and resume over the course of a long execution, potentially to ask questions and to clarify their work.
Famously, start and resume is the most human-like of interaction patterns because there's nothing more human than procrastination.
Right.
So it's clear that we expect a lot of our agents. And that means historically, we've pushed that burden onto you guys, the developers. We've expected a lot of you as well. In research that we conducted prior to launching Managed Agents, we found that developers were seriously struggling. So 1 in 3 were struggling with context management. Context at the right time can be incredibly powerful. It's the knowledge that the agent needs to do work. But context at the wrong time can be a huge distraction. Half of our developers were citing that infra concerns were their #1 production blocker. This is some of the concerns that Lance was talking about credential management, security and access, keeping a human in the loop. And then lastly, a majority of our users are saying that their agents are running with no formal observability. These agents are running off of predictive models, randomized outputs, and this is very unlike traditional software development of the past. How do you know if your agent is doing something good if it is producing random or probabilistic outputs? So enter Claude Managed Agents. We built this platform so that you don't have to. We combined infrastructure and harness, so tool permissioning, tool execution, automatic context management, checkpointing, retries, with foundational building blocks that Lance will go into in a bit later. That makes it easy to understand how to compose a customizable agent quickly. And then lastly, we paired it with a rich observability platform. We don't want these agents to be running on vibes. You should be able to understand exactly what your agent is doing and how you can improve it.
Yeah, that's right. And so using managed agents is actually really simple. The mental model is basically as follows. You're defining an agent, Agent you can think of as a configuration. It has a particular model, has a prompt, has tools, has skills. You're laying that out, and then you're allowing that agent to use an environment which you can configure. You can configure the networking, packages, and this is where the agent can, for example, write code. And any given execution of the agent is a session. Now, sessions can have resources, for example, GitHub repos. They can have something like an outcome, which we'll talk about a little bit more later. And these sessions emit events, which Jess will cover here briefly, that you can then handle and process and use to understand what the agent is doing.
So let's walk the event topology. As agents do more and more complex tasks, the event types that are produced are more and more complex as well. And so we've separated them into 4 broad categories. So there are user events. You steer the agent, you guide it, you interrupt it, you define exit criteria. There are agent events. These convey what the agent is doing, what tools it's running, how it's compacting its context over time, who it's delegating to. There are session events, which help you track the life cycle of your work. So is the agent running? Is it idle? Is it waiting for your inputs? And then lastly, there are span events. This is broader instrumentation that lets you group related events together. So we'll pivot to an example agent that we've built. We call it Pascal. It runs on a hypothetical grocery store's data set, a grocery store called Just in Time, and it produces rich analytics and insights in minutes, leveraging its preloaded container loaded with a set of Python packages. You can see every event in console, and you can even diagnose the event stream after the fact. So we'll walk through it with a bit of a demo. So we're starting the agent execution right now. You can see that the events are updating real time in console, and console supports a single pane of glass that lets you analyze the agent's configuration as well as its environment as you're looking at the events produced. Pascal has started to cook. It's starting to produce some outputs. It first starts with an analysis of the products. We're learning that bananas are really, really popular. The second output that it'll create is an analysis of the shoppers. And we're learning that Sunday morning is peak grocery time. And lastly, my favorite output is a bit of a predictive model where it's analyzing what is the reorder probability for a single customer given its demographic profile. Now that the agent has finished its completion, the full event stream is available in console, and we can analyze its performance. We offer a debug agent in console so that you can look at the event stream, analyze bottlenecks, figure out ways to improve the agent going forward, and take recommended actions. So it looks like it has identified a few bottlenecks, which we can then go fix directly in Claude Code.
Yeah, so what you saw is the console showing 2 really cool things. It's showing you the trace for everything that happened in the session, and allows you to analyze what happened using Claude to look at the session log and give you analytics, insights, and so forth. Now, how do you practically get started? First, I want to promote something that I worked on quite a bit, is a skill built into Claude Code and is shipped globally. In Claude Code today, if you just do /claude-API, you'll access our skill, which understands managed agents extremely well. And I use this all the time. In fact, I don't write a lot of managed agent code myself. I have Claude Code do it. It's a very nice trick, and I'll show you some very nice tricks later for how it can also be used to grab session logs and so forth. It uses the CLI to grab those logs. CLI is very powerful, lets you configure agents as, for example, YAML files, which you can check in. It allows you to grab sessions programmatically, which is very useful for working with code agents. And we also have cookbooks.
Artisanal code.
Yes.
So this is what we've been building with since we launched, but I wanted to also touch on some of the more advanced capabilities that we've been shipping over the last couple weeks. Each one extends the capabilities of the agentic experiences that you can offer. So first, there's multi-agent orchestration. Claude can clone itself. Claude can delegate to pre-configured additional agents. And this allows complex tasks to be decomposed into smaller units that are achieved with better fidelity. We have outcomes, which we've talked about a little bit earlier in this presentation, where Claude iterates until it satisfies predefined exit criteria. You define the goal, Claude keeps going until it's finished. A couple weeks ago, we launched Memory to public beta. With Memory Solutions, Claude doesn't have to start each new session fresh. Instead, it's reading and writing to persistent memory stores. And then lastly, today, my colleague Mahesh announced our Dreaming platform. Here, Claude is reflecting and codifying new learnings into new memories. Agents can literally improve between every single run. So we'll showcase another demo now that showcases how Claude Managed Agents uses outcomes and multi-agent to produce great outputs. Previously, you saw in console our analysis of a single session. Lance will walk through how we can do this programmatically at scale through the course of multiple sessions.
Yeah, so this is actually one of the most fun demos I had to build for this conference, and it came from a number of weeks ago. Angela, our head of product, actually prompted me with a question, what would the AGI-Pilled CEO have at his disposal, his or her disposal? So this is an interface where you just type in a question, it will query fake organizational data and render visualizations based upon the input for anything that this fake CEO wants to know. If you use, for example, the Claude app, you understand artifacts. It's basically just Claude producing SVG and rendering that, in this case in a browser, as a visualization. So we'll show this right now. Now, all I'm doing is I set up a Manage Agent. You can see session. It has a sandbox, orchestration to handle things like retries. I'm giving it one custom tool, the ability to render code to a browser. And what's going to do is, based upon the user's input, it's going to render visualization. We'll see that in a bit, which will show different, for example, graphs or tables based upon what this fake CEO wants to know. Now, this is where I used outcomes. And I want to make sure this is really clear because I thought this was really cool. So outcomes allows you to specify a rubric. You're passing instructions, which means the agent runs, and when the agent finishes, a separate subagent spins up, looks at the artifacts produced, in this case, my page. And for example, in this case, I specified produce timing and take a screenshot, do an analysis, send the analysis back to the main agent. So what was really cool here is I used outcomes to make this much faster. As you'll see shortly, the CEO will ask a question, it's going to render visualizations, and I want it to be fast. And I use outcomes to do that. Now, one nice thing is when I kick off a run with outcomes, the Manage Agent will iterate against that outcome over time. And when it finishes, in my particular case, I would look at the result, see the dashboard, and I might have feedback. I say, I don't like this. What I would do is I would then tell Claude Code my feedback, and it could use our CLI to pull the session log, reflect on the session, look at the rubric, look at the agent instructions, update those, and kick off a new session. This is what I call the outer loop. These two things work together really nicely. You have an inner loop that's using outcomes with Manage Agents, given a rubric, cook against that rubric, produce an output, and then this outer loop is looking at that output as a user and saying, okay, I don't like this, and allowing, for example, a code agent like Claude Code to modify the rubric or modify instructions and kick off a new session. So these two work really nicely together. And these are actually my results, and you'll see the demo very shortly. I start with a pretty inefficient baseline, and these are all discovered autonomously with Manage Agent just using the rubric to optimize timing. It figured out how to optimize or basically parallelize tool calls. It figured out to use fast mode, perform prompt optimization, and for inputs that produce multiple charts, it uses multi-agent, which saves around 7 seconds, going from around 37 seconds down to 10 seconds for rendering, and all figured out autonomously with a Manage Agent using outcomes.
So now we can see the results. Here's Boss Agent in action. We're able to analyze top-line metrics.
Yep. And I'm glad my music got included here.
Did Claude make that music?
Yes.
Nice.
Yeah, so this one's actually cool. This is actually using multi-agent to produce 3 visualizations simultaneously on my hypothetical AGI-Pilled CEO dashboard. Cool.
So I want to wrap some of these demos with just saying that the process of building Claude Managed Agents was made so much more meaningful because we were working with users like you. Throughout the whole course of this whole build of the platform, We got to partner with super innovative agentic partners who are trying to use Claude to extend the capabilities of their platforms. So Asana and Notion are highlighted here, but we heard feedback from all of you guys throughout the course of our public release, and it's been so gratifying to see what you guys are building on top of our platform. We're really excited to help you guys ship faster and faster. We're excited to keep pushing this platform forward, and please always reach out to us if you have feedback. These QR codes are where you can get started. One links to our developer docs, one links to a rich interactive quick start where you're able to walk our primitives and build an agent in minutes. And then, yeah, just another thank you to our great developer community.
Yeah, thank you. All right.
right. All right, everyone. Thank you for joining us again. And I am so excited for this conversation with Dario and Daniela. Let's give them a round. Woo! It is a delight to have you here at Code with Claude. We've been having a great day of sessions, demos, customer sessions, all sorts of fun stuff. But I wanted to ask you, maybe just a little bit zooming out, we talked a lot about the exponential in some of our conversations this morning and what it feels like to be on the exponential. And so as two people who are definitely on the exponential, we've talked a lot about growth and what it feels like. What does it feel like for you all?
Well, first of all, it's great to be here. Thank you so much for having us. At Anthropic, we have this little Slack emoji of the roller coaster. You guys know the one I'm talking about? But it's like an inflected roller coaster. So it's almost like it's like going straight up. And I think of me and Dario as riding at the front and the back of that roller coaster. I don't know if you all have ever, maybe not recently, been on a roller coaster. I'm not always sure which one of us is in the front and which one of us is in the back, but you get a different type of whiplash depending on which side you're on. And I think that's probably the best encapsulation of what it has felt like. It's like we're having a lot of fun. There's a ton of adrenaline. We're not totally sure that the operator of the roller coaster isn't like a 15-year-old who's doing a summer job of like questionable level of sound mind. But it's been great. It's fun. It's an adventure. There's a lot going on.
Yeah, the way I always think about the exponential is, it was me and the other co-founders who kind of, first predicted it through the scaling laws, over 10 years ago. And, we wrote down these lines on graphs that say like, well, first we're going to spend $1,000 in AMON, then 10,000, and then 100, it's going to go all the way to hundreds of billions. And, the model's going to be this good at this task and this good at this other task and that good at coding. And it is a remarkable experience to write down these lines on graphs and have the predictions come true. So in that sense, they are not surprising at all. And yet the actual experience of seeing what it's like is just, it's so crazy that you're shocked anyway, even though what you wrote down on the graph is exactly what happened. I'm always reminded of there's this famous scene in the movie Interstellar where they go to this, planet that's very close to a black hole. And so the planet has these waves that are like, 2,000 feet high. And I was a physicist. I know the math of general relativity, how much things can be sheared. But actually seeing it on human scale, like there's something deeply, this kind of deeply strange and unsettling about seeing it actually happen. And that's what it felt like every year at Anthropic. And I feel like this is the first year where like the rest of the world is kind of, is seeing it with us because we're so much in the spotlight. It applies to the internal growth of the company. It applies to our own work within the company, where for the first time we've seen the number of internal PRs inflect upwards due to the work that Claude is doing. And we've seen it externally because actually this is the first year we've grown faster than the exponential. So, we tried to plan very well for a world of 10x growth per year. In the first quarter of this year, we saw, if you were to annualize it, 80x growth per year in revenue and usage. And so that is the reason we have had difficulties with compute, right? We've planned for anything from it only grows a little to it grows 10x, and yet we saw 80x. And so, as you saw today with the SpaceX compute deal, we're working as quickly as possible to provide more compute than we have in the past. We'll continue to do so. We'll pass that compute on to you as soon as we can do so. I guess I hope the 80x growth doesn't continue because that's just crazy and it's too hard to handle. I hope for some more normal normal numbers, a mere 10x. But we will manage it absolutely as best we can, and we're every day trying to obtain even more compute that we can pass on to you. We're sorry if sometimes it takes some time, but we're gonna keep going to acquire as much as we can.
Awesome. Yes, yay for compute rate limits. You know, this is an audience of developers and builders, and that's really what today is about how we're making our platform better, because developers are who help us close the gap between what the models can do and what they're actually doing for real people out there. And, you know, both of you talk a lot internally about the importance of developers and builders. Maybe Daniela, I'd love to start with you. Like, how do you think about supporting this ecosystem, supporting this community?
Yeah, I mean, I'll start out by saying I think in many ways developers are the most important users of Claude, I think for a variety of reasons. You know, one is Anthropic ourselves are majority developers, right? If you think about how we develop this technology, what we're building, we learn so much from the developer community. It's like the best, it's the best partnership because it's first of all, I think it's a group that gives like honest feedback, right? And so I think that is actually really hard to get.
Yeah.
You know what I mean? It's like you build a product and you're like, I see some numbers, like those are nice, but like the genuineness with which the developer community, I think, engages with us is something that is so special. We have tried, you know, really from day one, I think Anthropic has always, you know, primarily built for developers, for businesses. I think we're a little bit unique in the AI ecosystem, you know, for that reason. And I think we have been very fortunate to be able to benefit from the feedback, from the engagement, from the community development. You know, developers are, you know, in my experience, they're very ecosystem and community oriented, which I think we are too, right? We're like, how do we build for this sort of broader ecosystem of people who are developing, by the way, some of the most inspiring, transformative technologies and building the most incredible companies in the entire world, right? There's been this renaissance of things in, you know, medicine and software development and, you know, financial service. I mean, it's like you pick the industry and there is an incredible developer or an incredible, you know, developer-based company that is transforming that industry, leveraging our tools sometimes. And I think that's such a special, that's both a privilege and a responsibility that I think Anthropic holds to say, you know, developers are really the backbone of like how we learn, how we build better tools for all of you. And I think that's a really special relationship that we feel like pride in and also a responsibility towards.
Yeah, I mean.
And this is an example of the developer community. I think part of what Daniela is saying is feedback is a gift. We hear the positive, we also hear the negative. Please keep it coming. It is part of how we know what's working and what isn't. And so we really value, and I'm sure as you're talking to people around, we really value all of that. And it helps us know what to do better. Sorry, Dario, back to you.
Yeah, you know, one thing I would say is that technology doesn't diffuse at kind of an even pace across the economy, right? And I think there's a spectrum where the software engineers are the ones who are fastest to adopt new technology. That's why there's so much kind of focus on this area, and it's the beginning of it. But it's like it's a foreshadowing of how things are going to work across the economy, right? And how the economy is going to be transformed by AI. So I think, you know, getting this right and really making it work for this community, it's kind of like a microcosm of how we have to, you know, make it work across the world. And I think one thing that you know, a dynamic we should watch. It was about I think it was roughly a year ago. There was an event like this, where Mike Krieger asked me, you know, when will there be the first billion-dollar company with one person? And I said 2026. And I think we're actually on track to achieve it. It hadn't quite happened yet. There's been like 2-person companies that are $1 billion built with AI. There's been like one person that's worth several hundred million dollars. So, but like, you know, we got 7 more months. So it's kind of. It's kind of, no, we do it. 7 more months in 2026, or 8. And you know, that's eternity on the exponential. But what I'm trying to say with this, though, is that there's an enormous ability for one person or a tiny set of people to do a set of things that are incredible, right? Where, before, if, you just had an idea and you had a vision, like, there's so many resources you'd have to accumulate over several years in order to make that vision happen. And I think there's a very unique opportunity for single individuals or very tiny teams to do things that are incredible, right? Where I think we moved from the models are writing code to, the models are helping us think of software engineering as a task, to the models are helping us think of, like, how can I build a business or an economic unit as a task? And so there's an extraordinary amount of opportunity for people in this room to kind of take advantage of that.
Yeah, it really feels like it's kind of removing barriers. There were all these barriers to, like, creating that kind of value in the world, and now, I guess the gauntlet has been thrown. We've got an 8-month timer, and I'm excited to see what comes of it. I would love to maybe hear what's going to change for developers. So Dario, you talked a little bit about what they can do now, and you've talked, in the past about how you expect Claude to build more with Claude. Can you just talk about how you expect things to move?
Yeah, I think there's several, like, maybe trends. One is going from single agents to kind of multiple agents. So the idea that, you have a bunch of these Claude, right? It's like managing a team, right? You have a bunch of Claudes running, and, like, you kind of farm a bunch of things out to your Claudes, and maybe some of the Claudes farm things out to other Claudes with, like, different so you have a kind of whole hierarchy, or we're gradually making our way to, like, the country of geniuses in a data center. We're starting with, like, a team of smart people in a in a room or something. We're working our way up.
It's a different exponential
in the country. So I think that's one trend that we're kind of already starting to see, and we're already, like, offering tools that can help do that. I think a trend that's related to that is, like, what we've done so far with Claude Code is, like, it helps kind of individuals to be more productive. But I think increasingly we're going to start thinking at the level of whole teams and organizations. And how can you make whole teams and whole organizations more productive in a way that is kind of more than just the sum of its parts. And then finally, I think in this area, as with everywhere else, if you want to think about what's next when something's working really well, you should always think about Amdahl's law, which is you speed one thing up, what are the things you're not speeding up? And so I think there are a bunch of things like security, like verification, like just if you're living in a world where you can, within an organization, write 3 or 4 times as many PRs as you could previously, you start to understand there are all these other things that are holding you back or that will go wrong if you speed up just that and not everything else. And so working to speed up those kind of other things so that we can greatly increase people's productivity, but we can do it smoothly and smoothly and productively and reliably. I think that's going to be very important.
Does that have any impact on how you think about training new models, or what the future of models looks like?
Yeah, I mean, that's true on several levels. I mean, I've already said many times we're using Claude to speed up Claude, right? That's kind of already something that's happening. But I also wonder if the things we're trying to do with the models could also influence how we build them. So when I talk about these things like kind of verification or kind of design quality or things like that, like one of the reasons training models for code and software engineering has gone so fast is that you have this verifiability, right? Where you train the model and it's like, you're able to verify it by running unit tests, and so that it has a lot of properties that simplify the process of training. But what you discover is that there are these, of course, aspects of the job that are not verifiable, right? And some of the is this thing really right? Can we find errors? Or are there security issues? Not quite as verifiable. And so train the models to be better at that, which I think will also make the models better at other things where they haven't made progress as fast as coding, like their ability to write or their ability to kind of do less less objective scientific tasks. So I think it's going to have benefits in many other areas. But I think we find even within software engineering, these kind of soft or somewhat subjective skills and abilities become surprisingly important because of Amdahl's law.
I would love to hear, we talk a lot about our mission internally. Like Daniela, as we just keep growing and the stakes of this whole industry keep getting higher, what should people know about our mission and about us as a company?
I think when I think about what Anthropic is trying to do, there's these sort of like two pillars, right? The first is around how do we develop this transformative technology in a way that is good for everybody, right? And I think this goal of Claude is this incredible tool. It has the power to really transform, what people build and how they create and the ambition level of what they can develop themselves. And I think there comes a huge amount of opportunity there, and there's also some risk, right? I think that we've talked about this a lot publicly. There's some risk to just labor disruption. There's risks to ensuring that the technology is developed safely, that it's good for people. And I think Anthropic's job, or what we try to do, is really think about how to balance these two things in equal measure. We have this internal cultural value called hold, light, and shade. And I think that it is such a good encapsulation of what we see about how the technology is being leveraged today, and also just our approach to putting the technology out into the world, right? I think Mythos and Glasswing are a great example of this. The potential to build something incredible with a model that capable is so vast, and we want to be a little bit careful about how we release it because of some of the security vulnerabilities, right? And I think that this is this kind of complicated dance that we do where we really want to get stuff out as quickly as we can. We're trying to build the best products and release the most powerful models, and we're just trying to do it responsibly. I think that is really the underpinning of the majority of actions that we take is sort of grounded across those two pillars.
I think that is, one of the things I find most meaningful about getting to work here is just thinking about how much everything is changing. And the fact that we're kind of all building in the industry right now, to me it feels like we're getting the chance to have a vote in how everything unfolds. And the trade-offs you're describing, that's just what I think of when I think of hold, light, and shade is as things move so rapidly, we get to build experiences that other people use to understand what the future looks like. So that's something I'm always really personally excited about. Maybe I'll ask a little bit about product. Both of you kind of lean in quite a lot on the product side. One thing that we talk a lot about is building for the exponential. I always think about product as kind of a bridge between the technology that exists and the problems that people have. And it's just a very interesting time because the technology is changing much more rapidly than we're used to. Can you talk a little bit about how you think about product building in this world?
So I love your way of putting that. It's like Dario and Daniela lean in a lot. And as Chief Product Officer, what Ami means is you guys are up in my business all the damn time. Can you please leave me alone and let me do my damn job?
All feedback is a gift. I enjoy every perspective.
But no, Ami is right. I think you have a hard job that you wear incredibly well. But I think in all seriousness, Dario and I both, we care a lot about the product, right? It's a representation of what we are trying to build at Anthropic. We want it to be useful for people. We want it to be accessible. We want the product to be good, right? Part of why I think we're leaned in so much is we feel very invested in ensuring that people that are using Claude are getting out of it everything that they can. And so I think our bothering you is really, I think, our way of, feeling like to the degree we can, we're standing up for our customers. We're standing up for our users who are building sometimes their whole business around the premise of what these AI models are capable of doing. And I think the other thing, maybe the thing that makes product at Anthropic unusual or different than how I've seen it done, at other companies I've worked at is product is sort of one input and research is another. I'm sure you've felt this in your role. Sometimes we're like, man, this is a clear, this is a great place where we should just be able to build something better that's easier to use. Or here's a product idea, we really want to enable people to be able to access it right out of the gate. But a lot of the time, product innovation is driven by what new capabilities emerge in the model. And I think coding is actually a great example of this, right? We didn't just sit out and say like, from day one, we're going to build a coding product. It was like once we saw that the models were able to write code at a reasonably accurate level, not perfect, we were like, this is interesting. It seems like a lot of people that are kind of Claude files are developers, right? And they're using it to write code. This has always been a community that we've worked well with, we've wanted to lean in with and engage and support. Should we build a tool for them, right? Should we build something that actually is going to enable people to be better at doing their day-to-day work in this way? But I think that's just an interesting dance inside the company where there's a component that is sort of, I don't want to say traditional product because nothing about Anthropic is traditional, but I think there's a component that looks like a normal product organization, and then there's part of the organization that's like, what is new from the models? What's happening on the research side? And how do we kind of marry those two things together?
Yeah, I would maybe take this from two lenses, which is building products for AI and building products with AI. And I think the internal experience at Anthropic, month by month and week by week, has given us lessons about both. So I think over the last few years, learned a lot of lessons about building products with AI, and in some ways it's been an advantage that I was a researcher. I was never in the era of building products without AI. So it's like you can end up in a situation where there are things you don't have to unlearn. You can just learn the new world from scratch. I think you got the essential difference, which is that if you go back to the product era in the 2010s, you had a slowly changing technological background, right? You were trying to do new things with, the kind of technology that was present, and of course, every once in a while, you'd have a new framework or a new way of doing it, but relatively slow. AI is moving lightning fast, and so there are a few consequences of that. One is that there are new products that are not possible with a given capability of model, but then when you take the next step, when you go far enough along the exponential, then suddenly they light up, suddenly they become possible. And so it puts a premium on internal experimentation, because you always want to be trying something. Even if you tried something that didn't work, you want to revisit it a few months later because it might work then when it didn't work before, which sounds a little bit crazy. But if we had tried to do Claude Code in like 2022, it wouldn't have worked because the models wouldn't have been strong enough. It was a frustrating experience. We did have some early things that were a little like Claude Code in 2022, and it was like, this is interesting, but you couldn't actually derive value from it because the models were dumb. So they were. I've been training these models since 2015. They were really dumb. They were really dumb back then. The second thing is that products reach their saturation when models start to get too good. So I think this has happened with chatbots, right? Like, it's a big market, lots of people use it, it's gonna stay around, but the ways in which we're making models smarter today are much more evident in today's Claude Code form factor and in more generally in the agentic form factor than they are on the chatbot code factor. So that's kind of the other side of the coin, which is that you always have to be thinking about what the new thing is, right? The way this business works isn't you make a product that becomes very big and then all the kind of stability sets in and you have to ask, you're constantly, not only are you able to make something new, you're constantly needing to make something new or at least update the things that you've made. So it's kind of constantly an innovation laboratory. And I think the other thing it means of particular relevance for developers and software engineers is API never really goes away as a market. Because the fact that it's always possible to build new products, that's true inside Anthropic, it's also true outside Anthropic. And so I actually think, both within code as an application, but just coders writing code with Claude for, medical applications, for, law, for finance, or there are going to keep being new applications because the models get smarter and they enable them. So that's building kind of in the age of AI. There's a newer thing we've seen maybe over the last year or 6 months, which is building with AI itself, like using AI to kind of, to enable the process of doing product development faster. That one is interesting, and again, we would go back to our old friend Amdahl's law, which is, we've found with the internal model acceleration, you can write 2 times as many, 4 times as many, 5 times as many. You see this within the company, but then you see what breaks. We've been able to ship a lot more products, than we could a year ago, and they're of pretty high quality, or I hope you think that. But it is possible to accumulate an extraordinary amount of internal technical debt when you ship that fast. And so then you have to say, well, can we also use the AI models to undo that technical debt or keep track of what it is that we're doing? And then you learn, the team has to work together in a totally different way. And these revelations come month by month, and you kind of learn how to do things in kind of a totally new way. So somehow it increases the tempo, not just of building, but in which the way you have to change the way you build as a team.
I really experienced that. I think the hardest part of it is you can get really familiar with the problems because the problems don't change that fast. The problems are about humans, we're going to have similar problems. But a thing that's hard is to learn to be fresh-eyed all the time about what the technology can do and constantly scan for that. And then I also feel it on a personal basis where your job just changes because you hit a new bottleneck, and the way you spend your day is just a little different. Maybe I'll just ask a couple more questions. Maybe Dario, very quickly, you talked a lot about model capabilities and how they change so often. Is there one thing that makes you most excited in the models that are coming in the next, call it 6 months?
I would say this idea of thinking at the level of the organization rather than just one person, again, it ties to this one person $1 billion business, which maybe that will turn out to be an underestimate. But just kind of the idea that you can both have an AI do the work of many people, but that when you have a team of humans, that AI is not just doing the work of many people working for one person, but that it does the work of many people many times over by operating within an organization of humans.
Awesome. And maybe I'll just ask to close, Daniela, one thing we talked about is some of the kind of developers or use cases we see that are just so inspiring. I talked a bit in the keynote about some of my favorites, whether that's people using it for efficiency at places like Stripe, doing major infra upgrades, but also people using it for these very personal and specific ways, like connecting kids to foster families faster. And I would just love to hear, what are some of your favorite examples of how you see people use the tools?
Yeah, I think even going back to the days when I was at Stripe, some of the something that I've just loved about the developer community in general is for every interesting challenge or problem there is in the world, there's an incredible dev somewhere who's trying to make that thing better. And I think getting to watch people build things with Claude that are just bringing so much utility and value and meaning to people around the world is really inspiring. I think, for me personally, a pilot that I've seen with some developers who are building these interfaces basically for mobile doctors in the global south. So places where it's really hard to reach an actual doctor because of access issues, right? You're down a dirt road somewhere, 50 miles from the nearest city, but people there still encounter health challenges. How do you actually work with this really smart technology to build these interfaces where people can just ask it a question, it can give you some medical advice, right? In a way that's sanctioned. I'm also just in general blown away by the medical research field and what is coming out of Claude, being able to accelerate biomedical research across many of the developers that work with us, that build on us. There are also just some really heartwarming individual examples. We have this user happiness channel at work. Some of my favorite ones, there's a developer who used Claude to help retrieve their wedding photos that were like on a corrupted hard drive. I thought that was so sweet, and just like such a like personal use case, but so meaningful. And then my last one, which is so random, is someone is using Claude to chart the growth of their tomato plants in their garden, and I was like, never in a million years would I have thought of it. But it's like I was like, do you have a live cam and can I subscribe to this? Because I would really love to see it. But I think just the range of things that people are able to do is just astonishing.
Well, Dario, Daniela, thank you both so much for spending time with us here. It's a pleasure to see you. Thank you to all of you for joining us. We've got a great rest of the day coming, but please join me in giving a round of applause to these co-founders.
Thank you.
Please welcome to the stage head of Claude Code of Anthropic, Boris Cherny, and creator of Bun at Anthropic, Jared Sumner.
Hello. All right, so this is a developer conference. We're gonna be doing a little bit of talking, but mostly we're just gonna be like coding. So this is for the developers in the room.
I'm gonna start by talking a little bit about how Bun uses Claude Code to build and maintain Bun, and also kind of how our setup works. And because it's kind of a slightly more advanced setup than what's common today. But first, I'm going to get a few agents running to just fix some GitHub issues.
This is classic Jared doing work during a talk.
So in Bun's repo, every time somebody submits an issue, we have a Claude bot automatically run and try to reproduce the issue. So you can see this person has this side effects, and this is like one of the most recent issues. And we can see that RoboBun, which is our bot, went and managed to reproduce the issue and submitted a PR automatically. And this PR is like, it has, all these PRs always have tests. It's one of the actual hard requirements before it can submit a PR. And so the challenge here is like, does this code look correct? And one of the things we do to check that is, does the test fail in the previous version of Bun and pass in this debug branch? And the bot actually can't submit a PR without that being the case.
And so this is, just to make sure I understand, so this is like every single issue that goes up in the Bun issue tracker, you have RoboBun automatically try to reproduce it before anyone looks at it.
Yeah, and this saves a lot of time because we have so many open GitHub issues. It really moves the challenge from just fixing and debugging the issue to, is this the right thing to merge? Like, is this the right fix?
How good is it? Is this doing like 100% of yours? Is it like 10%?
We can go to the insights and go to contributors, and then if we go last 3 months, and this is specifically to main, we can see that RoboBun is now a bigger contributor to Bun than I am. And that's with merging not all of its PRs for sure. You can see we have a lot of PRs open right now. The challenge is really, how do we know, can we merge the PR? And that's the test. And then the other thing that's really interesting about this is we have automatic code review bots that run, and then they're going back and forth. So like CodeRabbit leaves a comment, and then RoboBun leaves a comment, and then they go back and forth, and CodeRabbit did the.
I love this.
And it also marks the comments as resolved when it's done. And you can see they actually went a lot. Like, there's a lot of back and forth here. There's like 30 comments or something.
And so you're using like a combination of agents. So this is like code review, this is like Claude code review, and then also CodeRabbit. And like you're using them together.
Yeah. And I think basically like CodeRabbit is good for like kind of stylistic issues and things that are like, make sure that it follows the Claude MD. And then the Claude code review is really good at, here's this really subtle edge case that would have taken me like 30 minutes of reading all the code and having all the context to like figure out. And so it's really good at surfacing bugs that you need the full context to really understand. And I think basically it's really hard to actually have all this automation without having code review that is in the loop with Claude. They're replying, or replying is like very performative, but like fixing. And that's also a big part of like what used to take so much time when why PRs would take so much time to merge is because you'd have to like check out the branch locally, fix a lint error, then run the linter locally, then push it back up. And there's all this switching cost that's constantly there. And so so I think this is like an especially good use case for LLMs, because otherwise, like, it just takes up so much time to ship.
And I guess, like, especially for the Bun code base, because it's like, it's systems code, it's very easy to repro an issue and then see if the issue is fixed. Because this is kind of back to what we were talking about before with like this kind of verification loop. It's all systems code, so it's really like a test case on a particular architecture, and you can essentially like repro or verify anything.
Yeah, that's one thing that makes it easier in Bun's codebase is because it's a CLI tool. Because we don't need to run a browser to test things, but you can also just like have something set up to like take a screenshot or record a video or those sorts of things. In Bun's case, we don't need that, at least not yet. There's a couple of things we could do that for. Like we have some front end stuff that would be nice. But yeah, I think this is like the direction that I think is really interesting, is because it saves so much time. And this is something that like, this is specifically for Bun, but the more generalizable thing, because most products are not open source, is like, instead of an issue, maybe the starting point is like a customer support ticket. So like you could imagine automatically passing customer support tickets to a Claude bot to then go and try to reproduce the issue and then submit a PR and then having code review go back and forth. And that's where I think for a lot of companies, it becomes a lot more impactful. Because it just saves so much developer time.
We should think of some kind of name for this pattern. It's like adversarial code review or something like that.
Yeah, I don't know. But I do think like, there's also a few other things about this that's like, if you just do this, then it doesn't quite work. The very first step you need is to like make sure the development environment is set up. Like I think this has been talked about before, but like CloudMD is very important because otherwise it's going to just submit PRs that don't quite make sense for you to merge. So like we very much emphasize in Bun's codebase that it runs this special command to do the build, and this both builds and runs the command, so it like forwards the arguments. Because that's also one confusing thing is like because Bun has to be compiled. You want to make sure that it's running the actual changes and not like a debug build that's like stale. We also go into a lot of detail about how to run tests, how to write tests, where to put the test. And a lot of like, here's all the issues that we've run into previously. Like basically the pattern here is like every time that you find yourself repeating something, it should probably go in CloudMD. Because the question now is like, how do you make it maintainable to have lots of Claudes running all the time? And to do that, it needs to be written down. It needs to be documented. So like a really small detail is like, we check we have it like to make sure that Claude sees the error message. We make it print the error message before the like less informative conditions.
So this is sort of like you have Claude write a test, and then the test is bad or something about it doesn't work, and then you see this kind of repeated like once or twice, and then you just tell Claude, add it to the CloudMD so that every time in the future when you write a test, you do it correctly the first time.
Yeah.
So this is like compound engineering. It's kind of this.
Yeah. And then also it's helpful to like give an overview of where all the folders are, like how the code is laid out. And like about dependencies. Another thing I think is interesting is like making sure that it can read your CI errors and like build logs. Like you want to set up the agent to be able to read the code, like to do the full loop of like writing the code, testing the code works, checking CI, monitoring CI, and reading all the errors, so that way by the time it gets to a person, everything is like set up. Like the ideal is that you read the code and you have very clear indications that you can be high confidence to merge it, and the only way for that to be true is if it is set up for success.
It's interesting. I remember when we first met, you were talking about like your vision of like everyone being able to run hundreds of agents in parallel, and how that would work. And I feel like I didn't really get it at the time, although now like every night I'm running like hundreds of agents every single night. And I feel like now I'm finally there, but this is a thing that you've been thinking about for a long time. So it feels like this is sort of like the setup in order to be able to kind of scale up agents way more. Like you need the self-verification so that agents can run autonomously.
Yeah, like this has gone through many iterations in Bun's code base. We previously just had a Discord bot where I could just mention the bot and it would spin up a container. It didn't have like the CI stuff. It didn't have the code review stuff. And it's so much better now, especially with like Opus 4.7. All this stuff is getting so much better. Oh yeah, we can also check on how it's going. It looks like it created a PR, the first one. And it wrote tests.
So maybe while we look at this, I'm curious for like just to get a show of hands for people in the room. Like as people think about their development process, raise your hand if it looks something like this, where you have like a bunch of terminal windows or desktop tabs and you're kind of pasting in issues. Okay, so that's like maybe half of people. And then what if it looks like RoboBun or something more like that, where it's like closing the loop a little more? It's like the next level of abstraction. Starting to get there. Yeah, I think it's not surprising because I think model capabilities are just getting there. Like I think 4.7 is the first model where it's really felt like it's able to do this. And in the past, maybe you could do it with like a bunch of scaffolding. Like you just throw a bunch of tokens at it and it can kind of work. But now it's like efficient enough. You can actually do this day to day.
Yeah. Let's see. So the first PR is there. Let's see if it did any others. Okay, it did 2 PRs. This looks very plausible.
It's cool. And this before after, is this like, do you tell it to do that or?
Sometimes it does it. It's pretty good about knowing like when it should do that, like when it's like a string formatting thing. It also kept like Bun's style of the label, which is good because Node's style is slightly different. Let's see, does this change look good? Yeah, mostly what I'm thinking right now is it did this. This is good because like you don't want to write 1 byte at a time. You want to write in chunks, and then it used saturation but I don't like that. Or like it shouldn't have to do that.
Does anyone here actually know Zig? So, sort of.
But yeah,
that's how I feel looking at this code.
and you can see it followed the patterns from the CloudMD await using, and then that pattern of reading all the resolving all the promises at the same time.
And so, like, what's your workflow? Like, when you see something like this, are you usually going in and like commenting, or are you just going to wait for like code review to come in and drop a comment?
Usually, it depends on how complicated it is. In this case, I'll wait for, like, this one is actually pretty simple. I feel pretty high confidence that if the test pass, then I would probably merge this. But I still would wait for the code review for at least for the Claude code review one to run, just in case. Because what I really like about that is it will find things that from that aren't in the diff, that are like from tracing the control flow, which is what you want when it's like a human reviewing it, is like somebody who has a lot of context, who can think, what are all the edge cases that this might run into? And the signal to noise ratio is pretty good. It's something maybe like 10% of the time, a little bit more. It takes a lot of time to verify the changes are correct. This was kind of already true, like when it's a person pushing up a PR. But I think the challenge is like, how do we make sure to communicate sufficient proof that the changes are correct, or making it easier to like roll back things. I think those are kind of the two directions. But I think like for the majority of like simple issues, we should probably be pressing merge a lot more. And the bottleneck now is actually like CI and like making sure that in having like fully running the code, like the making sure all the test stuff works. But I think it's like basically there for like, and the large projects are still non-trivial, but also I've been doing some pretty large PRs lately with Claude, mostly not as much with RoboBun, but with like Claude Code. We recently added support for a built-in image processing library to Bun. I could probably pull up the PR. And that was Claude. And also we did a bunch of follow-up PRs too.
Yeah, it's like it's interesting because I think like when I look at different people using Claude Code, everyone is like at a kind of different level of like sophistication or kind of like adoption of this. And I think for me the hardest thing is the model changes very often, so I have to like constantly retune and kind of recalibrate to what it can do. And like as an engineer, it's hard because it's like a very weird technology. It's like the first technology I've used that's like that. And I sort of feel like this is actually, the way that you do it is ahead of how the Claude Code team does it for Claude Code itself. And to me, like the way the Claude Code team does it is actually very automated, but this is like even further ahead. This is like almost like full liftoff, like fully closed loop.
Like in the last 2 weeks, we've added an HTTP3 server to Bun. There's a PR for an HTTP2 server. There's fetch support for HTTP3 and HTTP2. There's this image processing API. There's the ongoing Rust rewrite, which may not ship. That's like the most ambitious one I've done so far. And done is too strong of a word because it's very much not done.
And so even something like this, like this is like a benchmark. So Claude ran this benchmark for you.
Yeah, Claude ran this benchmark. I gave it like this ran in like a separate on like a Linux box. And I was like, make it faster than Sharp, and that's basically what it did. I gave it like a few ideas, like, oh, you could try like read this code in JavaScript core to like figure out how to like avoid cloning the typed array when it's not strictly necessary. But like it then went and did it and figured it out. And like it's pretty crazy, honestly, because it was none of this would have worked several months ago.
Yeah, I feel like within Anthropic, like within an AI lab, you call this kind of thing hill climbing, and this is this idea that like if you give the model some sort of metric and then you give it a way to verify its result, you can just make it iterate and keep going until it hits that metric. And this is something like 4.7 I think is uniquely good at, and I think it's something really underutilized because I think it's the first model that's actually very good at that. And if you just give it a target, you give it a way to like improve the performance, and you give it a way to measure, it'll just like keep going until it's done if you let it go in auto mode.
Yeah, and we can also see like this is another case where like the code review comments was really, really helpful because like there was like in this PR there's like 100 comments or something, and it's just going and fixing everything. Like it goes on for a while.
And in the meantime, you're just working on something else.
Yeah, this was not like the thing I was 100% focused on. I was maybe like 10% focused on this. I was doing like 5 things at once. And this definitely wasn't possible like 6 months ago. 3 months ago, like this is like very recent that this is doable.
Okay. So how are our sessions doing?
Yeah, so we have one PR there. There's almost another PR coming up, it looks like, pretty soon. This one should be the trickiest one. It mostly looks good, though. It looks plausible based on these changes. I wouldn't exactly do it this way, but I think we need like a better, more optimized way to do this, because that's a lot of checks.
And looking at your setup here, so you mostly use CLI?
Yeah.
And do you always use auto mode for permissions?
Yeah, and then before that I used dangerously skip permissions.
No, you guys, I can delete stuff if you do that.
I think I'm not supposed to recommend that. But I think it's just not fun to wait for Claude to like press approve, because then you just like go off and do something else, and then it's just been sitting there. So that's why auto mode is really good, because it's actually like a real way to fix that instead of just like trusting.
And I also noticed like the input, like the little composer, it's stuck to the bottom of the screen, so you're using no flicker mode.
Yeah, I'm using no flicker. Honestly, I think we should just like make that the default, because it's so much better. Like you can see I can scroll really fast, and like you could scroll fast before, but like sometimes there would be a flicker, and now there's not.
Have folks tried no flicker mode for CLI? Yeah, a few people? Yeah. So it's like, we launched it on April Fools, so you can think, in hindsight it came across as a joke a little bit, but if you actually do quad code no flicker equals 1, quad, so just like set that environment variable, we totally rewrote the renderer that's running in the CLI. So it's using virtualized scrolling, virtualized selection, and so what this means is like constant memory usage, constant CPU usage, and also some nice stuff, like if Jared types, he can actually like click around the composer, and so you can actually click and mouse events work, which is pretty crazy for a terminal.
So I'm just also having it monitor the PR. And then you can see it ran some commands, and then it's going to go to sleep for 20 minutes and wake back up. 20 minutes is probably a little bit too long, but it's okay. Oops.
And what's that? Is that like using like a loop or something?
I think so. Yeah, and then it's, let's see, how else is it doing? And then the other ones are still, apparently it fixed an extra bug as well.
Okay, so we got, okay, so it's been, what? It's been like 20 minutes or so, 25 minutes, and we got one, how many PRs have we gotten? 2?
3 PRs.
3 PRs, that's not bad.
Yeah, and I think we'll get a 4th one once it finishes running the tests.
And then in the meantime, RoboBun is still running and kind of like generating even more PRs.
Yeah, every time somebody submits an issue, it tries to reproduce it.
Yeah. I kind of feel like the way Claude Code makes you think is every time there's a new bottleneck, you have to kind of automate that bottleneck, and then there's always some other bottleneck after, and you kind of move on to that. And like it started like writing code was the bottleneck, and now it's no longer the bottleneck. And then like verification and running tests, that was like the bottleneck, and it's no longer the bottleneck. And now there's like a deeper layer of verification. Maybe that's it. What do you think are the bottlenecks remaining?
It's definitely this deeper layer of verification. I feel like the bottleneck after that is going to be like planning, like what should we do and what should we not do, and what is the right way to fix this. And like ideally, Claude would be smart enough, or like we could trust Claude enough to merge the PRs by itself. And I think like in certain projects, you could probably do that and just have that be automatic completely. I think Bun is not yet, or like it's not yet there for Claude, or sorry, for Bun. But I think it'd be really cool if like we had the tooling for us to feel confident enough to do that.
So like right now, RoboBun, it doesn't like build features. It doesn't do like feature requests yet.
That's true. Yeah, it doesn't do feature requests, but we do also use it sometimes. So we can also mention it in either Discord or Slack, and it will like try to implement the feature. So sometimes when people are like, "Hey, Bun is missing this thing," then I just mention the bot, and maybe like an hour later, there's a PR. A bunch of times somebody's like tweeted at me something like, "This, can you fix this bug or whatever?" And that's basically what I do. And then I reply with a link to the PR.
Should we add a RoboBun account on Twitter?
And I think it can do feature requests, but I'm hesitant for it to implement literally everything anybody asks for in a GitHub issue, because that's kind of a lot.
Because in some ways, it's kind of crazy to put something like an image processing library inside a Bun, but like we talk about engineering taste, and there's like an element of taste that goes into that. Like you felt like that's a good idea, And like, we're not sure yet if Claude is at the point where it would also think this is a good idea. But at some point in the future, it'll get there. Maybe it's starting to get there.
And I do think that like PRs become suggestions. Like having like not merging PRs used to be like you feel bad if you don't merge like a coworker's PR because like they put work into that. But you don't have to feel bad when it's like Claude. So like if the PR is wrong or for whatever reason, then you can just not merge it. And but it does mean that like the bar for what you merge is like should it be there? Because I think there's also a difference with when it's like people. Because with people you don't want people to feel bad about their like lost work. So sort of in some ways it does actually end up raising the bar for what you decide to merge.
Yeah, it's interesting how like as the bottlenecks move, the dynamics change a little bit. It's sort of like having to trust each other, having to trust people on the team. This kind of changes a little bit. Now it's a little bit more about like, do we have the right automation and like, do we trust the automation, like as a group?
Yeah.
So I think we're almost at time. Is there any like maybe one last thing we wanna show people, or we can kind of check in on kind of like the progress that we've made?
I don't think so. Yeah, it's still going one last onto that fourth PR. And it's going back and forth, like found a bug and then fixed a bug. Looks like it's about to submit the PR now.
Okay, let's wait for this one. Love to have one more. This is like the cool thing about auto mode. It's like in auto mode, I can let like Claude runs like for hours and hours at a time. Like I run it almost every night. I'll just have a bunch of Claudes running in auto mode. And it's like before this, it just didn't work because it always got stuck at some kind of permission request. And that was crazy. Like this entire thing was one prompt. And that just ran for 30 minutes.
Yeah, this is all I said.
Okay, so it's pushing it.
It's about to submit the PR. That sounds like the right fix, too. This has been an issue that's been open for a long time.
Okay. And we got a PR.
Yeah, we can go into this issue and we can see how many upvotes it has. 20.
Yeah.
It's kind of a lot.
Cool. Maybe we can pause there. But to me, this is just like such a cool vision of where engineering is going, I think, for everyone in this room. And, we're going to see this first. We're going to have to figure it out first. And then everyone else is going to have to figure this out. So, like we were talking about this morning, just excited to be on this journey together. And like you can see, we haven't figured everything out yet. But I think like the mode that we're in is just constantly experimenting, constantly trying to see what the next bottleneck is so we can solve it.
It's very exciting. Because it's so cool. Yeah, like this stuff works.
Cool. All right.
Should I like?
Yeah, you can leave it.